Part 2. Enterprise Operations, Scale and Security Nightmares.
Having a running cluster is only 20% of the job. In Part 2, we are exposing the scale-breaking platform incidents, from GitOps sync storms wiping workloads, to autoscaler thrashing, telemetry crashes, and SSO failures. We will dive into the operational reality of running hundreds of clusters across multi-cloud environments, ensuring you can design and protect the platforms that run modern enterprise operations.
Part 1 Recap. The core infrastructure is secured.
We have completed our deep dive into the core infrastructure of the Kubernetes platform. Across these first 103 production incidents, we have covered the absolute boundaries of the cluster itself. We have mastered control plane stability, host operating system constraints, pod lifecycles, high-performance networking, and stateful storage. You now have the forensic skills to identify, isolate, and recover from any failure that occurs within the baseline execution layers of the cluster. In case, if you people missed Part 1, please check description for Part 1 link.
Transition from Part 1 to Part 2. From core to scale.
But having a stable, running cluster is only the starting point. When you run Kubernetes in a massive, multi-tenant enterprise environment, the biggest challenges often come from the scale itself. The tools you use to manage, automate, and secure your cluster, like GitOps pipelines, autoscalers, monitoring agents, and identity providers, can become your greatest failure points when pushed to the limit. To reach the staff level, you must understand what happens when these advanced platforms break under load.
Part 2. The Enterprise Frontier Production Incidents, 104 to 218.
In this second video of this Masterclass series, we will cover the final 115 incidents across these 9 critical operational domains. Category 6. Deployment, GitOps and Release Incidents Production Incidents 104 to 120. Category 7. Autoscaling, Capacity and Traffic Incidents Production Incidents 121 to 133. Category 8. Observability and Monitoring Incidents Production Incidents 134 to 149. Category 9. Security and Governance Incidents Production Incidents 150 to 168. Category 10. Cloud Kubernetes Platform Incidents Production Incidents 169 to 184. Category 11. Service Mesh and Advanced Traffic Incidents Production Incidents 185 to 191. Category 12. Platform Tooling, IDPs and CI/CD Production Incidents 192 to 201. Category 13. Disaster Recovery and Multi-Cluster Incidents Production Incidents 202 to 209. Category 14. High-Scale Reliability and Platform Failure Incidents Production Incidents 210 to 218. 115 high-stakes scenarios remain to complete your mastery of the Kubernetes ecosystem. Let's dive into Category 6.
Category 6. Deployment, GitOps and Release Incidents.
Continuous delivery is the engine of developer velocity, but in high-scale platforms, automated releases can quickly become vectors of cluster-wide collapse. In this category, we dive into the operational failures of modern deployment engines, from cascading GitOps reconciliation storms and broken Helm hooks to silent blue-green traffic leaks and destructive metadata deletes. We will test your ability to build bulletproof release guardrails and safely coordinate state synchronization across automated delivery pipelines.
Category 6. Deployment, GitOps and Release Incidents 104 to 120.
Here are the first 8 production incidents covering continuous delivery and release failures. Production Incident 104. Failed rolling deployment causing partial outage. Production Incident 105. Canary deployment routing traffic incorrectly. Production Incident 106. Blue-green deployment cutover failure. Production Incident 107. Broken Helm hooks blocking deployments. Production Incident 108. Incorrect values.yaml deployed to production. Production Incident 109. CRD upgrade incompatibility during Helm release. Production Incident 110. GitOps ArgoCD or Flux infinite sync loops and reconciliation storms. Production Incident 111. GitOps dependency deadlocks. Production Incident 112. ArgoCD app of apps cascading deletion accidentally wiping all cluster workloads. Production Incident 113. ArgoCD scaling failure with massive application count. Production Incident 114. Deployment stuck in progress, deadline exceeded state. Production Incident 115. Rollback failure after bad production deployment. Production Incident 116. Image tag or version drift between environments. Production Incident 117. CI and CD pipeline deploying incorrect artifacts. Production Incident 118. GitOps repository corruption impacting production sync. Production Incident 119. Terraform provider version drift breaking in for automation. Production Incident 120. Terraform state corruption or drift impacting cluster infrastructure. Total 17 production incidents for deployment, GitOps, and release. Let's start with Production Incident 104.
Production Incident 104. A rolling deployment is triggered for a core microservice, but the new version begins crashing on startup. However, because of misconfigured rolling update boundaries and a missing readiness probe, the API server terminates the old, healthy pods before confirming the readiness of the new pods, escalating a simple application bug into a total outage. How do you resolve this rollout failure?
Answer: the rolling update replaced healthy containers because its safety parameters were misconfigured. I would restore the workload and harden the rollout strategy using these steps. 1. Abruptly halt the rollout. Execute an emergency rollback command on the deployment resource to force the API server to stop the active rollout and restore the previous version. 2. Enforce concurrency boundaries. Configure safe max surge and max unavailable limits in the deployment spec to ensure healthy containers are never terminated prematurely. 3. Implement a readiness probe. Define a strict readiness check to prevent the API server from marking new pods as active before they are validated. 4. Configure progress deadlines. Set a strict timeout threshold to automatically abort and trigger a rollback if new pods fail to reach a healthy state within 5 minutes. Pro tip: for business-critical services that require zero planned downtime, consider setting max unavailable. 0 together with appropriate surge capacity to avoid partial capacity loss under heavy load, balancing rollout speed against available cluster headroom. Here is Kubernetes configuration, demonstrating how to configure safe rolling update parameters and readiness checks to prevent rollout outages. Disclaimer: always test code in a non-production environment. This code configures the update strategy to require the creation of at least one new container before any old, healthy pod can be terminated, eliminating partial outages during bad releases.
Production Incident 105. You configure a canary release to route 10% of production traffic to a new version of your checkout service using an Nginx ingress controller. However, due to a typo in your routing annotations, the ingress controller misinterprets the rule and begins routing 100% of live traffic to the unvalidated canary pods, causing a massive wave of failed transactions. How do you troubleshoot and recover?
Answer: this is a canary configuration failure caused by an annotation typo. When Nginx ingress or other ingress controllers encounter a malformed canary annotation, it can cause traffic to be routed incorrectly, including directing all traffic to the canary, depending on the controller's specific fallback behavior. To recover immediately, I would delete the canary ingress resource from the namespace, which forces Nginx to reroute all ingress traffic back to the stable production service. Next, I would analyze the controller logs to confirm the parsing failure and implement a pre-deployment validating script in our CI and CD pipeline to verify the syntax of our canary annotations before they are applied to production. Pro tip: canary annotations are prone to silent parsing failures. Instead of writing raw annotations in your YAML, consider using progressive delivery operators like Argo rollouts or Flagger, which manage the traffic splitting lifecycles via APIs and automatically roll back if the canary metrics drop.
Production Incident 106. You perform a blue-green cutover by updating a service selector to point from the old blue pods to the new green pods. However, due to long-lived, keep alive TCP connections, your ingress proxies and downstream microservices continue routing active traffic to the old pods, delaying the cutover and causing data inconsistency. How do you force a clean cutover?
Answer: the cutover failed because active TCP connections remained open on the old pods, bypassing the service selector update. I would force a clean routing switch using these steps. 1. Identify stale connections. Run network queries on the host nodes to verify if active, long-lived sockets are still routing traffic to the old pod IPs. 2. Leverage readiness and pre-stop checks. Ensure your pod templates have configured pre-stop hooks to allow in-flight connections to drain, and readiness probes to confirm pod health before traffic switches. 3. Enforce connection draining. Configure the upstream ingress proxies and service meshes with connection draining timeouts to gracefully close idle sockets. 4. Update service selectors. Apply the updated service manifest, ensuring the label selector points uniquely to the validated green deployment pods. Pro tip: updating a service selector only changes new routing lookups. It does not close existing open TCP connections. To guarantee a clean blue-green cutover, you must combine the selector update with connection draining at the proxy layer, a pre-stop sleep hook on the pods, and active readiness probes to prevent traffic leaks. Here is Kubernetes configuration, demonstrating how to define a service selector for a clean blue-green cutover. Disclaimer: always test code in a non-production environment. This code updates the service selector label to point exclusively to the green deployment version, redirecting new incoming connection requests to the updated pods.
Production Incident 107. A critical Helm upgrade relies on a pre-install hook, like a database migration job, to execute before upgrading the main application pods. The migration job fails and times out, but because the hook's delete policy was misconfigured, the failed job is left in the namespace, permanently blocking all subsequent Helm upgrade attempts. How do you resolve this release block?
Answer: this is a Helm release block caused by an orphan pre-install hook job. When a Helm hook fails, subsequent upgrades may fail because the failed hook resource remains and the release cannot progress. To resolve this immediately, I would use kube control to manually delete the failed migration job from the namespace. Once the blocking resource is cleared, I would update the Helm template annotations, adding a helm.sh/hook delete policy. Hook failed before hook creation directive. This ensures that Helm automatically cleans up any failed or previous hook resources before it attempts to initiate a new upgrade, preventing future release deadlocks. Pro tip: always configure explicit hook delete policies on your Helm hook templates. If you do not, failed pre-install or post-install jobs will linger in your namespace, blocking your automated CI and CD pipelines from executing rollbacks or hotfixes during active incidents.
Production Incident 108. An automated deployment pipeline accidentally deploys a Helm chart using a staging values.yaml file instead of the production configuration, pointing your production APIs directly to a sandbox database. How do you isolate this deployment error and prevent it in the future?
Answer: the configuration mismatch occurred because the deployment pipeline did not validate the values payload before execution. I would recover and secure the pipeline using these steps. 1. Trigger an immediate rollback. Run a manual Helm rollback command to instantly restore the previous, verified production configuration. 2. Enforce protected branches. Restrict write access to environment-specific values files using protected branches in Git, requiring manual peer approval for production changes. 3. Implement CI environment validation. Configure your CI and CD pipeline to validate the values payload against the target environment schema before running deployments. 4. Verify API endpoint handshakes. Add a post-deployment readiness check that validates the database connection string before marking the release successful. Pro tip: avoid running raw Helm upgrade commands in your production pipelines without dry run validations. Always integrate Helm template -- validate or Helm diff in your CI and CD checks to output the exact differences between active and incoming manifests, allowing your team to catch environment mismatches before they hit etcd. Here is bash code demonstrating how to use Helm template with validation to catch values.yaml mismatches in your CI and CD pipeline. Disclaimer: always test code in a non-production environment. This code compiles the Helm templates and validates them against the target API server's active schema, catching syntax errors and bad values before any resources are written.
Production Incident 109. You upgrade a third-party logging operator via a Helm chart, but the new release introduces a breaking change in the custom resource definition CRD schema. Because Helm does not natively upgrade existing CRDs by default to prevent accidental data loss, the deployment fails with schema validation mismatches, taking your logging platform offline. How do you resolve this upgrade deadlock?
Answer: this is a schema validation failure caused by Helm's CRD design choices. Helm intentionally skips upgrading existing CRD resources during a standard chart release to protect stateful data. To resolve this, I would first check the CRD schema changes in the operator's release notes, then manually apply the updated CRD manifests directly using kube control, following the operator's documented upgrade sequence. Once the API server compiles the new schema definitions, I would run the Helm upgrade command again, which will now succeed because the underlying custom resources can be validated cleanly against the updated API definitions. Pro tip: never rely on Helm to manage your CRD upgrades in enterprise environments. Always decouple your CRD management from your application charts. Deploying CRDs via a separate pre-upgrade pipeline, or using a dedicated GitOps repository to apply schema updates safely before running Helm upgrades.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip: whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 110. A GitOps controller like ArgoCD gets caught in an infinite synchronization loop. An external mutating webhook updates a field in the live cluster like replica counts or system labels, while ArgoCD continuously attempts to revert it back to the Git target state, generating 50,000 API writes in minutes and crashing the Kube API server. How do you break this loop?
Answer: the infinite sync loop occurred because an external controller modified the live state, creating a conflict with the Git configuration. I would stop the API storm using these steps. 1. Pause the GitOps sync. Instantly switch the ArgoCD application synchronization policy from automatic to manual to stop the API storm. 2. Identify the conflicting field. Compare the live resource manifest against the Git target configuration to locate the changing parameter. 3. Configure ignore differences. Update the ArgoCD application definition, adding an ignore differences block for the dynamically mutated field. 4. Restore automatic sync. Re-enable automatic synchronization, allowing the controller to ignore the webhook's changes while maintaining GitOps alignment. Pro tip: GitOps sync loops often happen with auto-scaled replica counts, dynamic certificates, or sidecar injections. Always configure ignore differences in your ArgoCD or Flux manifests for any field that is managed by an in-cluster operator like HP or mutating webhooks to prevent catastrophic API storms. Here is Kubernetes configuration demonstrating how to use ignore differences in ArgoCD to prevent infinite synchronization loops. Disclaimer: always test code in a non-production environment. This code tells the GitOps controller to ignore live cluster modifications made to the deployment's replica count, preventing conflicts with the horizontal pod autoscaler.
Production Incident 111. Your automated GitOps pipeline attempts to deploy a new monitoring stack. However, the synchronization fails because the pipeline applies the custom resource manifests before the custom resource definition CRD is fully registered and compiled by the API server. This creates a deadlock that halts the release pipeline. How do you resolve this dependency conflict?
Answer: the synchronization failed because the custom resources were evaluated before the API server registered and established the CRD. I would resolve the dependency block using these steps. 1. Pause the sync engine. Temporarily modify the GitOps controller config to pause the automatic synchronization loop. 2. Apply the schema first. Use kube control to manually apply the CRD manifests directly on the cluster first, forcing the API server to register the schemas. 3. Configure sync waves. Add the argocd.argoproj.io/sync wave metadata annotation to the CRD and custom resource files to enforce a strict deployment order. 4. Resume the synchronization. Re-enable the automated GitOps sync, allowing the engine to deploy the schemas in Wave 1 before applying the resources in Wave 2. Pro tip: sync waves help decouple your deployment order. While Helm manages hook dependencies locally, when you shift to GitOps, managing resources across separate directories requires explicit sync wave annotations to prevent the engine from trying to apply custom resources before the API server has registered and established the CRD. Here is Kubernetes configuration demonstrating how to use ArgoCD sync waves to resolve dependency deadlocks between CRDS and custom resources. Disclaimer: Always test code in a non-production environment. This code configures the sync wave metadata annotation on the resource, instructing ArgoCD to delay its deployment until all lower-numbered sync waves, such as backing CRDS, are fully reconciled.
Production Incident 112. A platform engineer attempts to clean up a stale testing pipeline, but accidentally deletes the root app of app's parent application in ArgoCD. Because cascading deletion is enabled by default, ArgoCD instantly begins deleting every child application and its physical resources in the cluster, threatening a total platform wipeout. How do you contain the deletion storm?
Answer: this is a cascading deletion failure caused by missing resource preservation rules. When a parent GitOps application is deleted, the sync controller automatically attempts to prune all child resources it was managing. To contain the deletion storm immediately, I would temporarily suspend the ArgoCD controller's reconciliation loop, or scale down the controller deployment to 0 if necessary to stop the active reconciliation engine. Only then would I use kubecontrol to patch the root ArgoCD application and remove the finalizer's block from its metadata, preventing further automated pruning of downstream resources. Pro tip: the app of apps pattern is highly efficient, but it represents a massive blast radius. Protect your root applications by explicitly disabling cascading deletions in ArgoCD and use resource preservation annotations to ensure that if the root app is deleted, your physical cluster workloads stay alive.
Production Incident 113. As your organization scales to 1,500 active applications, the single ArgoCD application controller pod begins crash looping. It runs out of memory, fails its liveness probes, and restarts constantly, freezing all deployment validations across the entire platform. How do you scale and shard the controller?
Answer: the controller crashed because it was overwhelmed by the scale of parallel resource reconciliation queries. I would scale and shard the controller load using these steps. 1. Increase controller memory. Update the ArgoCD stateful set spec, scaling up the container's memory allocation to prevent instant kills. 2. Configure controller sharding. Adjust the ArgoCD configuration to enable sharding, and scale the application controller stateful set replicas concurrently to distribute the reconciliation load. 3. Inject shard variables. Configure the argoct_controller_replicas environment variable in the controller container to tell the engine how many shards are active. 4. Tune cache expiration. Adjust the configuration map parameters to expand the application state cache timeout, reducing redundant API server polling. Pro tip: when your cluster scales beyond a few hundred applications, the ArgoCD controller can quickly become a bottleneck. Sharding the controller across multiple replicas is more effective than just adding RAM, as it distributes the network polling load across different nodes. Here is Kubernetes configuration, demonstrating how to scale and shard the ArgoCD application controller to handle massive application counts. Disclaimer: always test code in a non-production environment. This code configures the application controller replica count and sets the sharding environment variable, instructing ArgoCD to dynamically split the application reconciliation load across multiple horizontal pods.
Production Incident 114. A rolling update is deployed for a high-priority microservice. After 10 minutes, the rollout status command returns a progress deadline exceeded error, and the deployment hangs in an unstable, partially updated state, leaving some users routed to broken containers. How do you troubleshoot and unblock the release?
Answer: this is a rollout timeout failure. The progress deadline exceeded state indicates that the new pods failed to reach a healthy state within the configured time window, typically 600 seconds, causing the deployment controller to stop trying to progress the rollout. To troubleshoot, I would run kubectl get events in the namespace and inspect the pending pods to locate the exact cause of the failure, which is usually continuous kills, image pulling loops, or failing init containers. Once the underlying container bug is found, I would execute a rollback command to immediately restore the previous stable version, unblocking the active user paths while the application team fixes the code. Pro tip: do not just increase the progress deadline to bypass rollout hangs. A progress deadline exceeded state is almost always an application-level failure like missing database endpoints or bad intrapoint scripts. So investigate the underlying pod events first.
Production Incident 115. After a buggy deployment fails, you attempt to execute an emergency rollback using kubectl rollout undo. However, the rollback fails and hangs because the previous revision's manifest contains an immutable field change, such as trying to change a stateful set volume template or a service selector, leaving your cluster in a broken state. How do you force the rollback?
Answer: the rollback is blocked because the previous manifest attempts to modify an immutable field. I would handle the recovery safely using these steps. 1. Identify the immutable field. Run a dry run replace command on the previous revision's manifest to locate the exact immutable validation error. 2. Evaluate workload characteristics. Determine whether your active services, stateful identities, or database connections can tolerate transient deletion. 3. Recreate safely if tolerated. If the workload characteristics allow it, perform a controlled delete and fresh recreation of the resource. 4. Create a parallel resource. If deletion is unacceptable, deploy a parallel new resource with the updated spec and migrate traffic gradually. Pro tip: do not treat force replacement as a default rollback option. For stateful sets, services, and PVC-backed resources, a force replacement can break workload identity or cause data lockouts. So always evaluate workload characteristics before applying destructive changes. Here is bash code demonstrating how to execute a force replacement of a resource as a controlled last resort during a failed rollback. Disclaimer: always test code in a non-production environment. This code performs a controlled resource replacement by deleting the existing blocked resource and immediately creating the target backup spec in a single transaction, used only after verifying that the workload characteristics tolerate transient deletion.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 116. Your QA environment is fully functional, but after deploying the exact same release configuration to production, the application crashes because of missing API variables. You find that the deployment templates were configured to use generic tags like latest or main, allowing the staging and production containers to drift and run completely different application builds. How do you prevent tag drift?
Answer: this is a configuration drift failure caused by mutable container tags. When you use generic tags like latest or staging, the kubelet and the container runtime pull whatever build is active in the registry at that moment, leading to non-deterministic deployments where different pods run different versions of the code. To resolve this immediately, I would check our container registry logs to identify the exact image build used in staging, find its SHA-256 digest, and manually patch the production deployment manifest to use this immutable digest. For a permanent fix, I would update our CI and CD pipeline to inject unique git commit SHAs into the image metadata, ensuring we never deploy mutable tags to any environment. Pro tip: banish generic tags like latest or staging from your deployment templates. Using immutable SHA-256 image digests or specific git commit SHAs is the most reliable way to prevent silent configuration drift between environments.
Production Incident 117. A race condition occurs in your parallel CI and CD pipeline. 2 developers merge different branches at the same time, causing the runner to tag and deploy an untested feature branch image to production under an existing release tag. How do you resecure the pipeline boundaries?
Answer: this is a pipeline concurrency failure. When parallel workflows run without strict isolation or unique tag bindings, build processes can easily overwrite each other's image tags in the central registry, leading to untested code slipping into production. To resolve this, I would immediately run a rollback to the previous stable release tag, mark the corrupted image as unusable to prevent any further deployments, and retain it for forensic analysis. To prevent future race conditions, I would configure our CI and CD pipeline to restrict parallel production builds, forcing them to run sequentially, and configure our build steps to tag images exclusively with the unique git commit SHA of the merged branch, ensuring absolute build isolation. Pro tip: pipelines are prone to race conditions when multiple branches are merged quickly. Standardizing your CI and CD runners to build and test only against unique commit SHAs prevents untested code from being deployed under existing release tags.
Production Incident 118. An automated bot commits an invalid, unparsable YAML syntax error directly to the master branch of your GitOps repository. This breaks the parsing engine of the sync controller ArgoCD or Flux, which stops syncing all applications across the entire cluster, leaving your platform in a completely frozen state. How do you recover and protect the sync loop?
Answer: the synchronization froze because the GitOps engine encountered unparsable syntax on the main branch. I would recover and secure the sync loop using these steps. 1. Locate the bad commit. Review the Git repository logs to identify the exact commit that introduced the YAML syntax error. 2. Revert the commit. Instantly revert the corrupted commit on the main branch to restore the previous stable repository state. 3. Enforce pre-commit linting. Add a strict validation step in the CI and CD pipeline using schemas to catch syntax errors before merges are permitted. 4. Verify sync recovery. The GitOps controller will automatically detect the clean main branch, parsing the manifests and resuming cluster synchronization for the affected repository. Pro tip: an automated GitOps sync is only as good as the YAML on main. Integrating a strict validation step like kubeconfirm or a linter hook in your pull request checks is the most reliable way to prevent syntax errors from blocking or freezing synchronization for your affected applications. Here is bash code demonstrating how to use kubeconfirm to validate Kubernetes manifest schemas in your GitOps pipeline. Disclaimer: always test code in a non-production environment. This code parses all YAML manifests in the target directory and validates them against the official Kubernetes Open API schemas, catching syntax errors before they are committed.
Production Incident 119. A platform engineer runs a pipeline that automatically provisions new subnets in your cloud provider. However, because the Terraform configurations do not pin the provider versions, a silent minor version upgrade changes default behavior, deleting existing routing rules and taking several node groups offline. How do you stabilize the automation?
Answer: this is an infrastructure as code configuration drift. When you run Terraform without strictly pinning your provider versions, automated runs will automatically download the newest available provider binaries, which can introduce breaking API changes or default schema mismatches that alter your live resources. To recover the infrastructure, I would immediately run a git rollback on our Terraform repository to restore the previous configuration. Inspect the state file plan to identify missing elements, and execute targeted remediation steps only where necessary. To prevent future drift, I would update our Terraform code to use strict required_providers blocks with matching version locks, and generate a .terraform.lock.hcl file to force all runners to use the exact same validated provider binaries. Pro tip: pin your Terraform provider versions strictly using a .terraform.lock.hcl file. Unpinned provider blocks will eventually download breaking changes silently during automated runs, fracturing your infrastructure state.
Production Incident 120. 2 parallel CI and CD workflows execute Terraform runs on the same infrastructure directory at the same time. Because state locking is disabled in your remote S3 backend, the parallel runs create a race condition that corrupts the remote state file, locking down all future infrastructure updates. How do you recover and secure the state file?
Answer: the state file was corrupted because concurrent pipelines attempted to write to the S3 bucket without a locking mechanism. I would recover and secure the state using these steps. 1. Isolate the state file. Immediately disable the automated CI and CD pipeline runners to prevent further concurrent writes. 2. Restore from versioning. Access the remote S3 bucket, find the historical version of the state file from before the corruption, and restore it. 3. Verify state integrity. Run a dry run plan command using the restored state file to compare and verify the state against our actual live cluster infrastructure before resuming automation. 4. Enforce remote state locking. Update the Terraform backend configuration, adding a DynamoDB table to handle state locking. Pro tip: running parallel Terraform executions without a state lock is a recipe for disaster. Enforce remote state locking using DynamoDB, and enable S3 bucket versioning so you can easily roll back if a pipeline crash corrupts your state file. Here is Terraform configuration demonstrating how to configure an S3 backend with DynamoDB locking to prevent state file corruption. Disclaimer: always test code in a non-production environment. This code configures the S3 remote backend with a dedicated DynamoDB locking table, ensuring that concurrent runs are safely queued and cannot write to the state file simultaneously.
Category 6 Conclusion: Mastering GitOps and Releases.
Continuous delivery is the ultimate engine of developer velocity, but in high-scale platforms, automated releases can quickly become vectors of cluster-wide collapse. As we have seen in these 17 production incidents, securing the release pipeline is not about slowing down deployments, but about building strict platform-level guardrails by enforcing non-cascading deletion policies in ArgoCD, establishing explicit Helm hook delete annotations, and validating environment values files via pre-flight pipelines. By decoupling schema updates from application charts and ignoring dynamic runtime changes during GitOps reconciliation, you ensure that your platform remains stable and your delivery pipelines stay resilient under load.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 6 to Category 7.
But even the most perfectly automated, secure release pipeline is useless if your cluster cannot scale to handle the traffic those releases generate. If GitOps and release engineering are the foundry that delivers the applications, then autoscaling, capacity management, and traffic engineering are the nerves that dynamically expand the cluster's physical limits under load. When autoscalers lag, kernel-level CPU throttling occurs, or cloud quotas are exhausted, the platform stalls. We must now move from continuous delivery to real-time cluster expansion and traffic engineering. Autoscaling, capacity, and traffic incidents. Let's explore Category 7.
Category 7. Autoscaling, capacity, and traffic incidents.
Autoscaling is how your platform dynamically adapts to the real-world volatility of user traffic. In this category, we dive into the high-stakes failures that occur when your cluster's scaling engines are pushed to the limit, from HPA metric starvation and Karpenter consolidation loop thrashing, to cloud quota exhaustion, kernel-level CPU throttling, and sudden node pool disappearances. We will test your ability to design robust scaling buffers, tune horizontal and vertical scaling behaviors, and maintain platform stability under massive traffic surges.
Category 7. Autoscaling, capacity, and traffic incidents 121 to 133.
Here are the 13 production incidents covering autoscaling, capacity, and traffic failures. Production Incident 121. HPA not scaling metrics server or custom metrics issues. Production Incident 122. Metrics server failure breaking autoscaling cluster-wide. Production Incident 123. Scaling oscillation flapping causing pod churn. Production Incident 124. Karpenter consolidation loop thrashing disrupting workloads with misconfigured PDBs. Production Incident 125. Karpenter or cluster autoscaler node claim IAM failures preventing nodes from joining the cluster. Production Incident 126. Cloud quota exhaustion preventing cluster scaling. Production Incident 127. Traffic spike overwhelming Kubernetes cluster. Production Incident 128. Queue backlog growth leading to severe processing latency. Production Incident 129. CPU throttling despite available node capacity CFS quota issues. Production Incident 130. Underestimated resource requests causing cluster instability. Production Incident 131. Scale down accidentally removing critical workloads. Production Incident 132. Autoscaler reacted too slowly during an incident or traffic surge. Production Incident 133. Entire node pool disappeared during a deployment window. Total 13 production incidents for autoscaling, capacity, and traffic. Let's start with Production Incident 121.
Production Incident 121. During a sudden morning traffic spike, your checkout service API latencies jump from 50 milliseconds to 12 seconds. You find that the horizontal pod autoscaler HPA is failing to scale the deployment because the cluster's metrics server is throwing TLS handshake errors while trying to query the node's local kubelet APIs. How do you troubleshoot and restore scaling?
Answer: the HPA is failing to scale the deployment because the metrics server cannot scrape resource utilization metrics. I would restore the scaling engine using these steps. 1. Audit metrics server logs. Inspect the logs of the metrics server pod to identify specific TLS handshake or certificate verification errors. 2. Verify kubelet CA configuration. Ensure that the API server's kubelet client CA certificate matches the active certificates deployed on the worker nodes. 3. Bypass handshake validation. If necessary as an emergency only workaround during active incident response, Temporarily configure the metrics server with the kube let insecure TLS flag while certificate trust is being repaired. 4. Verify HPA scaling status. Once metrics collection is restored, run standard queries on the HPA to ensure it successfully reads CPU metrics and triggers scaling. Pro tip: do not wait for manual alerts to catch certificate expirations. Implement Prometheus monitoring rules targeting the API server _client certificate expiration seconds metric to trigger high severity alerts at the 30-day and 7-day mark, allowing automated workflows to renew them via your platform engine pipeline. Here is Kubernetes configuration demonstrating how to define a horizontal pod autoscaler targeting CPU utilization to enable dynamic scaling. Disclaimer: always test code in a non-production environment. This code configures the target CPU utilization threshold, directing the HPA controller to scale up the deployment replicas if average container usage exceeds 70%.
Production Incident 122. A platform-wide autoscaling outage occurs. Null of your cluster's HPAs can scale under load because the centralized metrics server has crashed. The logs show the process ran out of memory after a massive node pool scale-up, causing a cascading failure where all application groups hit their capacity ceilings. How do you recover and right-size the metrics aggregator?
Answer: this is a metrics aggregation failure caused by resource starvation. When the cluster scales rapidly, the single metrics server instance is overwhelmed by the increased volume of scraped targets, leading to an crash that freezes all HPA scaling decisions. To recover immediately, I would use our administrative bypass kubeconfig to restart the metrics server deployment, while increasing the container's memory allocation to 500 megabytes to unblock the current boot phase, or temporarily reduce scrape pressure if supported by our monitoring agent. Once stabilized, I would implement the Kubernetes resource estimator, or configure the metrics server deployment with vertical pod autoscaler VPA in recommendation mode, ensuring its CPU and memory requests dynamically scale based on the actual node and pod count of the cluster. Pro tip: the metrics server is highly sensitive to cluster size. If you run more than 100 nodes, avoid using static, low-value resource limits on your metrics deployment. Use the vertical pod autoscaler to dynamically adjust resources based on actual cluster scale, protecting your global auto-scaling engine from memory starvation crashes.
Production Incident 123. During a period of unstable network traffic, your core web service gets caught in a severe scaling oscillation flapping loop. The pods scale up to 100 replicas due to a brief traffic spike, immediately scale down when traffic drops, and then scale back up, creating massive container churn and database connection drops. How do you stabilize the scaling engine?
Answer: the workload is flapping because its scaling cooldown thresholds are configured too aggressively. I would stabilize the HPA behavior using these steps. 1. Audit active HPA behavior. Query the target HPA spec to see if custom scale up and scale down behaviors are defined. 2. Introduce stabilization windows. Configure a strict stabilization window seconds on scale down to force the HPA to wait and observe traffic trends. 3. Enforce gradual scale down rates. Implement restricted scale down step policies to prevent the autoscaler from terminating more than 10% of active pods in a single step. 4. Apply the prioritize policy. The scheduler will now use the most conservative policy, preventing rapid, redundant pod termination during traffic dips. Pro tip: default HPA configurations are designed to scale down quickly. In high-traffic environments, always configure a custom behavior block with a 5-minute to 10-minute scale down stabilization window to smooth out traffic valleys and prevent resource flapping. Here is Kubernetes configuration demonstrating how to use the behavior block in HPA to configure stabilization windows and prevent scaling flapping. Disclaimer: always test code in a non-production environment. This code configures the scale down behavior, restricting the HPA to only decommission a maximum of 10% of active replicas in any given 1-minute window.
Production Incident 124. Your platform team migrates to Karpenter to optimize cloud compute costs. However, during off-peak hours, Karpenter enters an aggressive consolidation loop, spinning up and terminating host instances continuously to pack nodes. This thrashing triggers continuous pod evictions, disrupting workloads because several applications run without pod disruption budgets. How do you stabilize the node consolidation loop?
Answer: this is a node consolidation thrashing issue. Karpenter is designed to aggressively consolidate resources to minimize cloud spending. But if your workloads lack pod disruption budgets (PDBs), this continuous packing can create severe application instability. To resolve this, I would update our Karpenter node pool configuration, changing the consolidation policy to focus primarily on empty nodes, or configuring strict budgets to restrict the maximum percentage of nodes Karpenter can disrupt simultaneously during maintenance windows. Finally, I would deploy strict PDBs across all active workloads, ensuring that Karpenter is prevented from consolidating nodes until disruption constraints permit the eviction. Pro tip: Karpenter's consolidation engine is highly efficient but needs guards. Always define a default disruption budget in your Karpenter node pool to rate limit node terminations, and use the Karpenter.sh/do not disrupt true annotation on critical, single replica workloads to explicitly shield them from automated consolidation sweeps.
Production Incident 125. During a sudden traffic surge, Karpenter successfully triggers the provisioning of 20 new EC2 instances in AWS, but the instances remain in a pending state and never join the cluster. Kube API server logs show that the new nodes cannot authenticate because Karpenter's auto-generated node claim cannot map the required IAM instance profile due to missing AWS control plane permissions. How do you recover the provisioning path?
Answer: the newly created nodes cannot join the cluster because the IAM permissions for Karpenter's node profile are misconfigured. I would restore the provisioning path using these steps. 1. Audit Karpenter IAM roles. Inspect the IAM role associated with the Karpenter controller to ensure it has permissions to pass roles to new nodes. 2. Verify node class configuration. Check the active EC2 node class definition to confirm the correct IAM role is specified. 3. Manually authorize the profile. Ensure the target IAM role is registered in your cluster's Access Entry API or the legacy AWS Auth config map, depending on the active EKS authentication mode. 4. Force node re-provisioning. Terminate the unauthenticated, pending EC2 instances to force Karpenter to launch new authorized nodes. Pro tip: modern Karpenter v1.0.0 and newer auto generates instance profiles based on the IAM role you specify in your EC2 node class. Ensure your Karpenter controller's IAM role has the IAM:pass role permission allowed for your specific node role. Otherwise, new instances will spin up but get blocked from joining the EKS cluster. Here is Karpenter configuration demonstrating how to define the EC2 node class with an explicit IAM role mapping to allow new nodes to join the cluster. Disclaimer: always test code in a non-production environment. This code specifies the AWS IAM role that Karpenter will use to automatically generate the instance profiles for new EC2 nodes, allowing them to successfully authenticate and join the EKS cluster.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 126. During a Black Friday traffic surge, your cluster's autoscaler triggers a massive node scale-up, but the new worker nodes fail to launch. The autoscaler logs indicate a critical failure. Instance limit exceeded, as the AWS account has exhausted the region's hard vCPU limits, leaving 200 high-priority checkout pods stuck pending. How do you contain and remediate this resource block?
Answer: this is a cloud provider quota exhaustion. When your cluster scale-out requests exceed the pre-allocated virtual CPU vCPU limits of your AWS or GCP region, the cloud provider will reject new instance creations, leaving the cluster unable to expand. To contain the incident immediately, I would use an administrative local kubeconfig to identify low-priority non-production deployments in the same cluster and manually scale them to 0, if appropriate according to business priorities and existing scheduling policies, reclaiming existing node capacity for our critical checkout pods. For a permanent fix, I would submit an emergency service quota increase request to the cloud provider and configure our Karpenter node pool limits to enforce a strict headroom budget, ensuring our dynamic scaling does not blindly hit cloud infrastructure ceilings during peak events. Pro tip: do not wait for a major event to check your cloud quotas. Always monitor your usage against limits using cloud-native tools, and configure your cluster autoscalers with a safety buffer. For example, capping Karpenter limits at 80% of your account's regional vCPU quota to prevent sudden, hard provisioning rejections when you need capacity the most.
Production Incident 127. A sudden flash sale triggers an immediate 10 times traffic spike that overwhelms your core API gateway. Because VM provisioning takes up to 3 minutes, the cluster autoscaler cannot launch new nodes fast enough, and the existing nodes experience severe CPU starvation and crash before the new capacity arrives. How do you implement a rapid scale-up buffer?
Answer: the nodes crashed because VM startup latency prevented the autoscaler from delivering compute capacity in time. I would implement an over-provisioning buffer using these steps. 1. Configure negative priority classes. Create a low-priority class resource with a negative value to act as an over-provisioning tier. 2. Deploy low-priority pause pods. Deploy a set of dummy pause pods that use the negative priority class and request matching node CPU and memory. 3. Reserve node space. The scheduler will place these pause pods on active nodes, forcing the autoscaler to keep hot standby node capacity ready. 4. Trigger instant preemption. When real application pods scale up, the scheduler will instantly evict the low-priority pause pods, reclaiming the node space in milliseconds. Pro tip: Cloud VM boot time is too slow to handle sudden spikes. Use negative priority pause pods to reserve hot compute space on your nodes. During traffic spikes, the scheduler will instantly preempt the pause pods to let your real application containers run, while the autoscaler quietly provisions new VMs in the background. Here is Kubernetes configuration, demonstrating how to use a low-priority pause pod deployment to over-provision cluster compute capacity. Disclaimer: always test code in a non-production environment. This code configures the pause pods with a negative priority class, directing the scheduler to immediately evict them and give their physical node space to real application workloads during traffic spikes.
Production Incident 128. During a heavy data import event, your backend order processing workers experience severe latency. The RabbitMQ backlog grows to 100K messages, but the traditional CPU-based HPA fails to scale the worker pods because their CPU utilization is low as they wait for database I/O, leaving the queue backlog to grow unchecked. How do you configure event-driven autoscaling?
Answer: this is a metrics misalignment scaling failure. Using standard CPU or memory utilization for scaling is ineffective for queue consumers, because a container can be waiting on I/O consuming almost zero CPU, while a massive message backlog is building up. To resolve this, I would deploy KEDA Kubernetes event-driven autoscaling in the cluster, which allows us to configure autoscaling based on direct external event metrics. I would configure a KEDA scaled object that connects directly to the RabbitMQ API, monitoring the actual queue length or other supported external metrics. This allows the platform to scale the worker pods up dynamically based on the backlog size, even when container CPU usage is flat, ensuring rapid processing recovery. Pro tip: for asynchronous workers, standard HPA is the wrong metric. Leverage KEDA to scale your worker pods based on queue length or lag. This keeps your consumer count aligned with the incoming workload volume, reducing processing latency and avoiding unnecessary cloud spend on idle containers.
Production Incident 129. Application teams report that their high-throughput API gateway pods are experiencing severe P99 latency spikes and connection timeouts. Upon checking the metrics, you find that although the host worker node has 60% idle CPU capacity, the gateway containers are being heavily throttled by the Linux kernel's completely fair scheduler CFS. How do you eliminate CFS quota throttling?
Answer: the containers are being throttled because their CPU limits are misaligned with the Linux kernel's CFS quota allocation period. I would resolve the throttling using these steps. 1. Audit throttling metrics. Check Prometheus metrics targeting the container_CPU_CFS_throttled_periods_total value to identify which deployments are impacted. 2. Evaluate limit strategy. Analyze the application's CPU requests and limits, evaluating whether hard CPU limits are appropriate for latency-sensitive services or if they should be completely bypassed. 3. Enforce node-level reserves. Ensure the node's local kubelet is configured with proper kube-reserved memory and CPU limits to protect system processes. 4. Deploy resource linter policies. Implement validating admission policies to reject any new workloads that attempt to deploy without appropriate CPU requests. Pro tip: CPU limits can cause severe kernel-level throttling even when the node is mostly idle, due to how the CFS quota period is calculated. For latency-sensitive workloads, consider defining a high CPU request but removing the limit entirely, allowing the application to burst into host cycles safely without being throttled. Here is Kubernetes configuration, demonstrating how to define container resource requests without hard CPU limits to prevent kernel-level CFS throttling. Disclaimer: always test code in a non-production environment. This code configures the container resource constraints without setting a hard CPU limit, allowing the application to utilize available host CPU cycles during bursts without being throttled by the kernel's CFS scheduler.
Production Incident 130. An application team deploys a new service with extremely low resource requests, for example 50 M CPU, and 100 MB memory to save costs. Under load, the containers consume massive resources up to their high limits, causing CPU starvation and memory exhaustion on the host node, which severely degrades kubelet responsiveness and may destabilize the node. How do you enforce resource request integrity?
Answer: this is a host-level resource starvation incident caused by underestimated requests. The scheduler uses container requests to place workloads on nodes, so when requests are set artificially low, the scheduler will pack too many pods onto a single node. Under load, these pods attempt to burst up to their limits simultaneously, overcommitting the physical node and starving critical system services like the kubelet. To resolve this immediately, I would use kubectl to find and scale down the misconfigured deployments to restore node stability. For a permanent fix, I would configure a namespace-level limit range to automatically inject minimum requests and implement a vertical pod autoscaler VPA in recommendation mode to continuously suggest realistic resource request values. Pro tip: under provisioning requests to save money is a platform anti-pattern. If you set your requests too low, you risk severe node-level starvation and cascading failures under load. It is safer to align requests closely with observed peak utilization to ensure the scheduler can make accurate placement decisions, keeping your compute platform stable.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 131. During an automated scale down, Karpenter terminates an underutilized node to save costs. However, because a critical single replica application pod lacks a pod disruption budget and does not have disruption protection enabled, Karpenter evicts and terminates it, leading to unexpected transaction loss during off-peak hours. How do you protect critical workloads during scale down?
Answer: the pod was evicted because Karpenter identified its host node as a candidate for consolidation and no disruption protection was configured. I would protect the workload using these steps. 1. Assess disruption protection. Audit the pod template to verify if Karpenter disruption annotations are defined. 2. Add disruption exclusions. Inject the Karpenter.sh/do not disrupt annotation directly into the pod metadata. 3. Enforce pod disruption budgets. Deploy a strict pod disruption budget to ensure the API server rejects eviction requests if availability is threatened. 4. Verify consolidation behavior. Monitor Karpenter's logs to confirm that the engine now skips consolidating nodes hosting protected pods. Pro tip: do not rely solely on pod disruption budgets to protect single replica workloads during consolidation. Adding the Karpenter.sh/do not disrupt. True. Annotation directly to the pod tells Karpenter to completely bypass the host node during cost optimization sweeps, preventing accidental evictions of non-auto-scaled containers. Here is Kubernetes configuration, demonstrating how to use Karpenter do not disrupt annotation to protect pods during node consolidation. Disclaimer: always test code in a non-production environment. This code configures the disruption exclusion annotation, telling the Karpenter engine to completely bypass the host node during automated cost consolidation sweeps.
Production Incident 132. During a sudden morning traffic surge, the horizontal pod autoscaler triggers pod scale-ups, but the cluster autoscaler is too slow to provision new nodes. The existing nodes experience severe CPU starvation and network timeouts, and by the time the new instances finally boot up 3 minutes later, the system is in a degraded state. How do you troubleshoot and accelerate the auto-scaling response?
Answer: this is an auto-scaling responsiveness failure. When a traffic spike occurs, the cluster autoscaler is delayed because cloud VM boot times typically take several minutes, and the auto-scaling loop's default polling interval can introduce additional lag. To resolve this, I would evaluate migrating our node management to Karpenter, which directly queries the cloud provider's EC2 APIs and bypasses the slow node group abstractions to provision new instances in under a minute. Alternatively, if we must stick to cluster autoscaler, I would modify its startup flags to reduce the -- scan interval to 10 seconds and utilize a most allocated or priority expander to accelerate instance provisioning, ensuring new compute capacity arrives before the existing nodes are completely starved. Pro tip: cloud VM boot latency is a physical limitation. If your workload experiences massive, sudden traffic spikes, relying purely on reactive autoscaling will eventually fail. Consider combining Karpenter's rapid provisioning with a low-priority over-provisioning buffer to absorb the immediate impact of traffic surges.
Production Incident 133. During a scheduled deployment window, an automated Terraform update modifies a Karpenter EC2 node class subnet tag selector. Because the disruption budgets are misconfigured, Karpenter instantly identifies the entire active node pool as out of date, terminating all host instances at the same time before verifying if new nodes can successfully boot, dropping 100% of your cluster's workloads. How do you recover and protect the node lifecycle?
Answer: the entire node pool disappeared because Karpenter's disruption rules did not rate limit node terminations during updates. I would recover the cluster and secure the node pool lifecycle using these steps. 1. Halt active disruption. Instantly update the Karpenter config map or scale down the Karpenter deployment replicas to stop the controller from terminating any remaining hosts. 2. Revert the tag selector. Revert the bad Terraform configuration change in Git and apply the corrected subnet tag selectors. 3. Enforce disruption budgets. Update the Karpenter node pool manifest, adding strict disruption budgets to limit active node terminations. 4. Allow gradual re-provisioning. Restart the Karpenter controller, allowing the engine to gradually replace out-of-date nodes while maintaining cluster capacity. Pro tip: Karpenter can easily wipe out your entire cluster's compute capacity during updates if limits are omitted. Always configure a strict disruption budgets block in your Karpenter node pool, such as limiting disruption to 10% of nodes, or one node, at a time to force the engine to execute gradual, rolling replacements of out-of-date infrastructure. Here is Karpenter configuration, demonstrating how to configure disruption budgets in a node pool to prevent cascading node deletions during upgrades. Disclaimer: always test code in a non-production environment. This code configures the disruption budget to limit Karpenter to terminating a maximum of 10% of nodes concurrently, preventing total compute capacity drops during automated upgrades.
Category 7 Conclusion. Mastering Autoscaling and Traffic.
Autoscaling and capacity management are the absolute limiters of platform performance. As we have seen in these 13 incidents, dynamic scaling is not just about setting minimum and maximum container boundaries. It is about managing the physics of cloud infrastructure and the Linux kernel. A true platform engineer does not solve a capacity crisis by blindly scaling down core services or using non-functional force flags to bypass PDBs. Instead, they implement disruption-aware auto-scaling, reserve standby capacity, and choose workload-specific scaling strategies using tools like KEDA and Karpenter. By securing your compute boundaries, you ensure that your platform can absorb sudden spikes safely while keeping cloud spending under control.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 7 to Category 8.
But even the most highly scaled, perfectly buffered cluster is a black box if you cannot see inside it. If autoscaling and capacity management are the nerves of your platform, then observability and monitoring are the eyes. When Prometheus crashes due to high cardinality label explosions, log forwarders leak memory on host nodes, or alert storms flood your on-call teams with duplicate notifications, your platform is left running blind in the dark. We must now move from compute scaling to real-time cluster forensics and telemetry, observability and monitoring incidents. Let's explore Category 8.
Category 8. Observability and monitoring incidents.
Observability is the foundation of site reliability. In this category, we dive into the high-stakes failures that occur when your telemetry systems crumble under the weight of their own data, from Prometheus high cardinality OOMs and fluent bit memory leaks, to logging pipeline backlogs, rejects RADOSCPU spikes, and silent alerting failures. We will test your ability to tune the metrics engine, optimize log routing, secure your alerting pipelines, and maintain forensic visibility when the platform is undergoing extreme stress.
Category 8. Observability and Monitoring Incidents 134 to 149.
Here are the 16 production incidents covering telemetry and monitoring failures. Production Incident 134. Prometheus OOM killed because of high cardinality metrics explosion. Production Incident 135. TSDB corruption in Prometheus. Production Incident 136. Cube state metrics memory explosion under high scale. Production Incident 137. FinOps tooling Kubicost or open cost causing cluster OOMs by scraping massive Prometheus metrics. Production Incident 138. Silent monitoring failures resulting in missing alerts during major outages. Production Incident 139. Alert storms flooding PagerDuty or on-call teams. Production Incident 140. Grafana dashboards unavailable during incidents. Production Incident 141. Loki or ELK ingestion backlog causing delayed logs. Production Incident 142. Loki or FluentBit rejects RADOS regular expression denial of service causing CPU spikes. Production Incident 143. Elasticsearch logging cluster turning RED unassigned shards. Production Incident 144. FluentBit or FluentD crashes causing log loss. Production Incident 145. Distributed tracing backend overload. Production Incident 146. APM or tracing agents Datadog, New Relic memory leaks or causing kernel panics. Production Incident 147. Audit logs filling node disks completely. Production Incident 148. Poor alert tuning causing monitoring blind spots and alert fatigue. Production Incident 149. Telemetry pipelines overloaded during traffic surges.
Production Incident 134. During a sudden traffic surge, your central Prometheus instance is terminated with an OOM killed status. After restarting, it immediately crashes again during the wall replay phase. You discover that a developer deployed an updated application that injects raw user IDs and dynamic transaction UUIDs as labels into its Prometheus metrics, triggering a massive high cardinality metrics explosion that starves the heap. How do you recover?
Answer: Prometheus crashed because high cardinality labels saturated the metrics engine. I would recover the metrics database and sanitize the ingestion using these steps. 1. Bypass ingestion storm. Temporarily stop the Prometheus scraping configurations for the misconfigured application namespace. 2. Enforce metric relabeling. Configure a metric relabeling rule in your Prometheus config to drop the high cardinality transaction and user labels at the scrape stage. 3. Safely handle corrupt WALs. If the wall replay is completely frozen, take a backup of the TSDB directory if feasible, and temporarily move the active segment files out of the data directory as a last resort to force a clean startup. 4. Verify scrape sanity. Re-enable the namespace scraping and monitor the total active series count to ensure it remains within stable heap limits. Pro tip: high cardinality is the most common cause of Prometheus outages. Avoid letting dynamic fields like user IDs, email addresses, or transaction UUIDs slip into your metric label keys. Use PromQL queries targeting scrape_samples _scrape to audit metrics, and proactively drop non-static labels at the ingestion layer. Here is Prometheus configuration, demonstrating how to use metric_relabel_configs to drop high cardinality labels at the scrape stage. Disclaimer: always test code in a non-production environment. This code configures the metric relabeling rule to drop the specified high cardinality labels during the scrape process, preventing those dynamic values from exhausting Prometheus memory.
Production Incident 135. Following a sudden physical power loss on your storage-backed worker node, Prometheus fails to start up, with its logs displaying critical block header corruption errors in the time series database TSDB. The platform team is completely blind to system metrics during an active incident. How do you recover the local storage?
Answer: this is a local TSDB corruption event. When the underlying host crashes ungracefully during active metric write cycles, the active in-memory blocks can get corrupted, preventing Prometheus from parsing the TSDB index on startup. To resolve this, I would first check for recent WAL segment logs and evaluate using official DB repair tools to verify the block checksums. If simpler recovery steps fail, I would SSH into the host node, locate the Prometheus data directory, identify the corrupted block folders by timestamp, and temporarily rename or isolate those directories. This allows the Prometheus process to bypass the corrupted database segments and boot up cleanly, restoring real-time metrics visibility while accepting a minor loss of historical metrics for that corrupt time window. Pro tip: never run production Prometheus instances with single-disk storage backends. Always enforce remote storage writing like Thanos, Cortex, or Victoria metrics to offload your metrics to a durable, highly available object store, ensuring your local TSDB only acts as a short-term scratchpad that can be wiped without losing historical telemetry.
Production Incident 136. As your cluster scales to support thousands of active replica sets and microservice pods, the centralized Kube State Metrics KSM pod begins crash looping. It runs out of memory, fails its liveness probes, and restarts constantly, breaking all cluster dashboards and metrics scraping. How do you scale the metrics exporter?
Answer: KSM crashed because it was overwhelmed by the sheer volume of active resource metadata. I would scale and restrict the metrics exporter using these steps. 1. Increase exporter memory. Update the KSM deployment resource request to provide more memory headroom for metadata caching. 2. Restrict scraped resources. Configure the startup flags to explicitly disable unnecessary high-volume resources for your specific environment. 3. Enable namespace filtering. If appropriate for your platform architecture, restrict KSM to only monitor specific business-critical namespaces. 4. Implement controller sharding. Deploy KSM in sharding mode, distributing the resource scanning load across multiple horizontal pods. Pro tip: by default, Kube State Metrics watches and caches every single object in the cluster, which is highly memory-intensive. To prevent crashes in large environments, customize the resources flag to explicitly exclude unnecessary high-volume resources for your environment, keeping the exporter memory footprint bounded. Here is Kubernetes configuration, demonstrating how to restrict Kube State Metrics resources to optimize memory usage. Disclaimer: always test code in a non-production environment. This code configures Kube State Metrics to only watch and cache the specified core resources, preventing the memory usage from inflating due to high-volume resources like secrets.
Production Incident 137. Your organization deploys a third-party FinOps tool like KubeCost or OpenCost to monitor cloud spend. However, during a high-scale event, the cost aggregator pod attempts to run a massive, undownsampled Prometheus query, consuming 100% of Prometheus's memory, triggering a cascading crash that blinds the entire on-call team. How do you recover and protect your telemetry?
Answer: this is a query-driven telemetry outage. Cost monitoring tools frequently run heavy, unoptimized Prometheus API queries to calculate cluster spend, which can easily saturate the Prometheus memory pool if there are millions of active series. To resolve this, I would immediately restart the Prometheus pod to clear the blocked memory, temporarily throttle or disable the heavy, unoptimized queries from the cost monitoring tool, and isolate its query access to a dedicated read-only replica if supported. Once the system is stabilized, I would reconfigure the cost monitoring tool to enforce downsampling and query caching, and configure Prometheus with strict query.max concurrency and query.max samples limits to reject any unoptimized sweeps before they can starve the heap. Pro tip: never let third-party applications execute unrestricted queries directly against your primary Prometheus instance. Always establish query timeouts and limit the maximum number of samples a single query can retrieve using the query.max samples startup flag, protecting your telemetry from resource-hungry background analyzers.
Production Incident 138. A severe cloud provider network outage takes down your core database cluster. However, the on-call team receives 0 alerts or pages. You discover that the Alertmanager routing daemon failed silently hours ago due to a disk fill lock, blocking the delivery of all critical outbound alerts. How do you implement a dead man's switch to prevent silent failures?
Answer: the alerting pipeline failed silently because we lacked an external validation mechanism. I would configure a heartbeat alert using these steps. 1. Configure a heartbeat alert. Create a Prometheus rule that is configured to always fire, for example, value is greater than 0 under standard cluster operations. 2. Set up an external receiver. Configure Alertmanager to route this specific watchdog alert to an external monitoring service. 3. Enforce outbound heartbeats. The external service expects to receive this heartbeat ping at a regular interval, like every 5 minutes. 4. Trigger escalation on silence. If the external service does not receive the ping, it identifies that your alerting pipeline is dead and pages the on-call team immediately. Pro tip: an alerting pipeline is only as good as its own monitoring. Always configure a continuous watchdog dead man's switch alert in Prometheus and route it to an external service like dead man's snitch or pager duty. This ensures you are alerted if your internal monitoring stack goes completely silent. Here is Kubernetes configuration, demonstrating how to define a Prometheus rule for a continuous watchdog heartbeat alert. Disclaimer: always test code in a non-production environment. This code creates a synthetic alert that is hard-coded to always fire, creating a continuous heartbeat stream that Alertmanager routes to your external validation service.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 139. A single rack switch failure in your private cloud data center takes down 50 nodes. Instantly, Alertmanager generates 8,000 unique alerts, sending a massive alert storm to PagerDuty that completely paralyzes the on-call team with duplicate pages. How do you design an alert deduplication and grouping strategy?
Answer: this is an alert storm crisis. When a massive infrastructure failure occurs, sending individual alerts for every single container pod eviction creates extreme alert fatigue and hides the actual root cause of the failure. To resolve this, I would update our Alertmanager routing configurations, introducing strict group_by and group_wait parameters. By grouping alerts by their common metadata such as alert name, cluster, and namespace and setting a group_wait of 30 seconds, Alertmanager will collect the individual notifications, deduplicate them, and send a single group notification rather than thousands of individual alerts. Pro tip: design your alert routing with high-level grouping parameters. Always group application alerts by namespace and service name, and use group_wait to let Alertmanager collect and consolidate the burst of events before executing the external routing API, protecting your on-call engineers from fatigue.
Production Incident 140. During a major production incident, hundreds of developers and stakeholders log into Grafana simultaneously to check the health status of the system. This massive surge in requests exhausts Grafana's default local SQLite connection pool, locking up the dashboards and leaving the engineering team completely blind. How do you restore and scale the dashboard backend?
Answer: this is a dashboard backend failure. By default, Grafana uses a local SQLite database file to manage user sessions, dashboards, and configurations, which quickly deadlocks when hit with high concurrent write and read operations. To resolve this immediately, I would restart the Grafana pod to clear out the locked database threads and update our ingress configuration to rate limit non-essential user requests. For a permanent fix, I would migrate Grafana's backend database from SQLite to a dedicated Postgres SQL instance and configure Grafana with multiple stateless replicas and highly available session management to distribute the connection load safely across our compute pools. Pro tip: never run production Grafana instances with the default SQLite database. If your platform serves more than 50 developers, always migrate the backend to a highly available Postgres SQL or MySQL instance, enabling you to scale Grafana horizontally to survive the traffic surges of active incidents.
Production Incident 141. During a massive scaling event, your log collection backend like Grafana Loki experiences high write latency, causing log ingestion to fall 30 minutes behind reality. Developers attempting to debug active application errors see stale, outdated log lines in their dashboards, rendering active troubleshooting impossible. How do you resolve this ingestion backlog?
Answer: the logging pipeline fell behind because the Loki ingesters were saturated by the write volume. I would scale and optimize the ingestion queues using these steps. 1. Identify ingestion bottlenecks. Query the Loki ingester metrics to verify if the delay is caused by slow disk writes or memory buffer saturation. 2. Scale the ingester replicas. Scale up the Loki ingester stateful set replicas to distribute the incoming log streams across more nodes. 3. Optimize ingest buffer options. Update the Loki configuration map, expanding the chunk idle period and increasing the max write buffer limits. 4. Verify real-time synchronization. Monitor the log latency metrics in Grafana to ensure the ingestion delay returns to sub-minute levels. Pro tip: log ingestion lag is usually caused by unoptimized chunk flushes. If your logs are written in micro batches, the ingester spends more time writing metadata than actual logs. Scale your write buffers and allow the ingesters to hold logs longer in memory before flushing them to object storage, keeping in mind that increasing chunk idle period reduces flush frequency, but also increases memory residency. Here is Loki configuration, demonstrating how to optimize the ingester block to handle high concurrency logging spikes. Disclaimer: always test code in a non-production environment. This code configures the Loki ingester parameters, allowing the engine to buffer log chunks longer in memory before flushing them to object storage, which reduces physical write overhead.
Production Incident 142. Suddenly, several FluentBit logging agent pods running on your worker nodes hit 100% CPU usage and crash. You find that a developer released an application with a non-standard log format, and FluentBit's regex parser got caught in an exponential backtracking loop regular expression denial of service, starving the host node of CPU. How do you resolve this CPU exhaustion?
Answer: this is a logging parser failure caused by an unoptimized regular expression. When a logging agent evaluates structured logs using complex, nested regular expressions that contain overlapping groups, an unexpected log pattern can trigger infinite backtracking in the regex engine, causing CPU usage to spike to 100% and stalling the node. To resolve this immediately, I would update our FluentBit config map, temporarily disabling the custom regex parser for the offending application. For a permanent fix, I would work with the application team to output their logs in structured JSON format instead, enabling FluentBit to parse the fields natively via JSON decoders, which avoids expensive regex evaluation. Pro tip: avoid using custom, complex regular expressions in your global logging agent parsers. Standardizing your applications to output native JSON logs allows your log forwarders to parse fields natively, which completely avoids expensive regex evaluation.
Production Incident 143. A sudden worker node crash causes your Elasticsearch logging cluster status to turn yellow, leaving the cluster in a degraded state without full redundancy. Running diagnostics reveals that several replica shards for the current day's index have become unassigned, increasing the risk of permanent data loss if another node fails. How do you safely restore replica allocation and recover cluster resilience?
Answer: the logging cluster turned yellow because the database replica shards became unassigned after the node crash. I would recover the cluster status using these steps. 1. Determine allocation failures. Query the Elasticsearch Allocation Explanation API using curl to understand why the shards are unassigned before attempting any manual rerouting. 2. Verify host availability. Check if the physical or cloud host node that was hosting the unassigned shards has successfully recovered and joined the cluster. 3. Execute a controlled reroute. If the host is permanently dead, execute a manual reroute command via the REST API to force allocate the unassigned replica shard to a healthy active node. 4. Monitor recovery status. Check the cluster health metrics to ensure the status returns to green, restoring full transactional redundancy across the platform. Pro tip: if your logging cluster frequently turns yellow after node upgrades, check your replica count. Never run production logging indices with number _of_ replicas. 0. Always configure at least one replica to ensure that if a node dies, the cluster can instantly promote a replica shard to primary without dropping active log writes. Here is bash code demonstrating how to use the Elasticsearch REST API to force allocate unassigned replica shards to healthy nodes. Disclaimer: Always test code in a non-production environment. This code executes an Elasticsearch cluster reroute command, instructing the master node to bypass standard waiting times and immediately allocate the unassigned shard to a healthy host.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 144. During a traffic spike, Fluent bitlog forwarders across your cluster begin dropping logs, and some instances crash due to errors. You find that our Elasticsearch logging backend experienced a minor slowdown, causing FluentBit to run out of memory because it was buffering the backlog exclusively in RAM. How do you enforce backpressure safety?
Answer: this is a log forwarder backpressure failure. When the central log storage backend slows down, FluentBit must queue the incoming container logs. If FluentBit is configured to buffer this queue in RAM, it will quickly hit its container memory limit and get killed under load, losing all logs currently in memory. To resolve this, I would update our FluentBit configuration, transitioning the buffer storage type from memory to file system-backed storage. Depending on the deployment model, I would configure a persistent volume or appropriate node local directory on the node and set storage.type file system, which ensures FluentBit writes the backlog queue to disk during downstream bottlenecks, protecting the agent's memory footprint. Pro tip: avoid buffering log forwarder queues exclusively in memory. Always configure storage.type file system in your FluentBit input sections to utilize host-level disk buffers or persistent volumes. This ensures your logging agents can handle downstream backend slowdowns without crashing or dropping logs.
Production Incident 145. Your distributed tracing backend, such as Jaeger or Tempo, experiences a complete outage during a traffic spike. The OpenTelemetry OTel collector pods are crash looping due to errors, and their upstream connection buffers are exhausted because they are attempting to ingest and process 100% of the raw, unsampled trace data. How do you implement tail-based sampling?
Answer: the tracing backend crashed because it was overwhelmed by the sheer volume of unsampled traces. I would implement tail-based sampling using these steps. 1. Audit trace volume. Query the OpenTelemetry collector metrics to identify the current trace ingestion rate and queue drops. 2. Introduce tail-based sampling. Update the OpenTelemetry collector configuration to enable the tail_sampling processor. 3. Define sampling policies. Configure rules to discard 95% of successful HTTP requests, but preserve 100% of traces containing errors. 4. Reroute the collectors. Restart the collector pods to apply the new sampling rules, reducing the outbound trace volume to the backend by 80%. Pro tip: ingesting 100% of successful traces is an anti-pattern that inflates massive storage bills. Leverage tail-based sampling in your OpenTelemetry collector to filter out the noise, keeping only a small percentage of successful requests while ensuring every single failure is preserved for forensic analysis. Here is OpenTelemetry collector configuration, demonstrating how to configure tail-based sampling to reduce tracing backend load. Disclaimer: always test code in a non-production environment. This code configures the OpenTelemetry tail sampling processor to buffer traces in memory for 10 seconds, allowing the engine to inspect the final trace status before deciding whether to save or discard it.
Production Incident 146. Following the rollout of an updated eBPF-based application performance monitoring APM agent on your worker nodes, several host systems suffer sudden kernel panics. You find that the APM agent's low-level kernel probes conflict with another active security agent, triggering a complete operating system crash. How do you resolve this host-level conflict?
Answer: this is a system-level telemetry conflict. Modern APM and security agents utilize eBPF extended Berkeley packet filter to attach hooks directly to host system calls. While eBPF allows multiple programs to coexist, incompatibilities between kernel instrumentation components, driver issues, or buggy agent implementations can destabilize the host, triggering a complete operating system crash. To resolve this immediately, I would roll back the APM agent daemon set rollout and update the host system configurations to reboot automatically after a panic. For a permanent fix, I would adjust the APM agent's config map, disabling the raw eBPF-based socket probing and falling back to standard user space tracing or sidecar-based metrics, which isolates the telemetry collection from the host's kernel space. Pro tip: eBPF-based monitoring is incredibly powerful, but introduces host-level risks. Before deploying any daemon set that loads eBPF programs, Always validate compatibility against existing host security tools in a dedicated, isolated node pool to catch kernel-level lockups before they impact production nodes.
Production Incident 147. Your API server audit logging is configured to write directly to the control plane host node's file system. However, due to a missing log rotation policy, the audit log files silently grow to 200 gigabytes, completely saturating the host system partition and triggering a disk pressure alarm that freezes the entire control plane. How do you configure rotation parameters?
Answer: the master node ran out of disk space because the API server's audit logs lacked a retention policy. I would configure rotation limits using these steps. 1. Isolate the bloated logs. SSH into the master node and move the large audit log files to a temporary backup directory to restore disk space. 2. Configure max size limits. Edit the API server's static pod manifest, adding the audit log max size flag to force rotation at 100 megabytes. 3. Configure retention boundaries. Add the audit log max backup flag to restrict the maximum number of rotated files the system will keep. 4. Restart the API server. Save the manifest changes, allowing the kubelet to restart the API server static pod with the new rotation limits active. Pro tip: audit logs can grow incredibly fast in high concurrency environments. Never let your API server write audit logs to the host without defining strict audit log max size and audit log max backup flags, ensuring the local logging directories are automatically bounded on the disk. Here is Kubernetes configuration, demonstrating how to configure API server audit log rotation parameters to prevent disk exhaustion. Disclaimer: always test code in a non-production environment. This code configures the API server to write audit logs to a specific host path and sets the maximum file size to 100 megabytes and the maximum backup retention count to 10 files, preventing disk exhaustion.
Production Incident 148. During a high-stakes cluster outage, your on-call engineers miss a critical database connection failure alert. You discover that the team was suffering from severe alert fatigue, having been spammed with over 400 non-actionable alert pages, like CPU greater than 80% on staging or pod, restart on dev in the last 24 hours, causing them to mute their pagers. How do you re-architect the alerting system?
Answer: this is an alert fatigue failure. Spamming on-call engineers with high frequency, non-actionable notifications creates an environment where critical production outages are missed because they are buried in the noise. To resolve this, I would immediately disable all paging alerts for non-production environments and transition them to Slack or email tickets. Next, I would work with the platform team to re-architect our alerting taxonomy based on strict SLIs and SLO service level indicators and objectives, reserving paging alerts only for symptom-level failures that directly impact users such as high error rates or latency, while routing cause-level warnings such as disk usage at 80% to standard ticketing queues for daily remediation. Pro tip: avoid configuring alerts based on static resource thresholds like CPU usage. If a node has high CPU, but the applications are serving requests smoothly, paging an engineer is a waste of resources. Focus your paging alerts on customer impacting metrics like P99 latency or transaction error rates, keeping your infrastructure warnings in non-disruptive Slack channels.
Production Incident 149. During a massive network traffic surge, your central OpenTelemetry OTel collector pipeline crashes, and the metrics on your cluster-wide dashboard completely stop updating. The logs show that the collector's internal memory buffer filled up and triggered an crash because it was receiving 10 times the standard volume of metrics and logs. How do you implement backpressure and scale the pipeline?
Answer: this is a telemetry pipeline scale failure. When a traffic spike occurs, logs and metrics volume explodes. If your OpenTelemetry collector is configured with static, non-buffered memory limits, the internal queues will quickly overflow and trigger an crash. To resolve this immediately, I would restart the collector deployment while temporarily increasing the pod memory requests. For a permanent fix, I would configure the OpenTelemetry collector's memory_limiter processor with strict backpressure thresholds, telling the pipeline to apply backpressure and sampling policies as configured when memory hits 80% of its allocation. This ensures the collector stays alive and continues processing critical data rather than crashing and blinding the entire system under load. Pro tip: scale your telemetry collectors horizontally based on CPU or memory, and always enforce a memory_limiter processor in your open telemetry configs. This provides a safe backpressure mechanism, allowing the collector to gracefully drop non-critical metrics or logs during traffic surges rather than suffering a complete heap crash. Observability is the ultimate safeguard of platform reliability. As we have seen in these 16 production incidents, maintaining visibility is not just about installing dashboard templates. It is about managing high-velocity telemetry pipelines. From mitigating Prometheus cardinality explosions with strict ingestion relabeling rules, to preventing fluent bit backpressure crashes via file system buffers, and implementing tail-based sampling in the open telemetry collector, you must protect your monitoring stack from its own data. By establishing outbound heartbeats and avoiding brittle regex parsers, you ensure that your team is never left blind during a high-severity production outage.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 8 to Category 9.
But even the most visible, perfectly monitored platform will crumble if it is exposed and insecure. If observability and monitoring are the eyes of your cluster, then security and governance are the shield. When Kubernetes secrets are leaked to public repositories, service accounts are hijacked for privilege escalation, or expired certificates break inter-service communication inside your mesh, the entire platform becomes a vector of enterprise ruin. We must now move from systems visibility to deep cluster hardening and compliance, security and governance incidents. Let's explore Category 9.
Category 9. Security and Governance Incidents.
Security in Kubernetes is a continuous zero-trust hardening effort. In this category, we dive into the high-severity failures that occur when your cluster's boundaries are compromised or misconfigured, from accidental secret leaks and RBAC privilege escalations, to expired vault tokens, root container escapes, and MTLS certificate collapses. We will test your ability to enforce pod security standards, build secure secret rotation pipelines, isolate namespace traffic, and maintain strict platform compliance under active external threats.
Category 9. Security and Governance Incidents 150 to 168.
Here are the 19 production incidents of this category covering security, hardening, and compliance failures. Production Incident 150. Kubernetes secrets leaked accidentally. Production Incident 151. External secrets operator ESO rate limited by AWS or Vault, taking down cluster-wide secret sync. Production Incident 152. Service account privilege escalation vulnerabilities. Production Incident 153. Excessive cluster admin permissions abused in production. Production Incident 154. Expired vault tokens breaking workload authentication. Production Incident 155. Secret rotation causing application downtime. Production Incident 156. Privileged or root containers deployed accidentally causing security breaches. Production Incident 157. Crypto miner malware detected inside cluster. Production Incident 158. Vulnerable container images exploited in production. Production Incident 159. MTLS certificate expiration inside service mesh. Production Incident 160. Spire or SPIF identity issuance failures. Production Incident 161. Cert manager renewal failures, cluster-wide rate limits, or webhook failures. Production Incident 162. Image signature verification blocking deployments co-sign or Kyverno. Production Incident 163. Unauthorized east-west traffic between namespaces. Production Incident 164. Publicly exposed Kubernetes dashboard or API endpoint. Production Incident 165. Runtime security alerts triggered from Falco. Production Incident 166. Kubernetes audit webhook overload. Production Incident 167. Supply chain attack through compromised container images. Production Incident 168. OIDC or SSO DEX or key cloak downtime blocking all developer kubectl authentication. Total 19 production incidents for security and governance. Let's start with Production Incident 150.
Production Incident 150. A developer accidentally commits a base 64 encoded Kubernetes secret manifest directly to a public Git repository during a rapid hotfix. Although an automated scanner flags the commit within minutes, the credentials containing production database passwords are already exposed, threatening an imminent security breach. How do you contain and remediate this leak?
Answer: the credentials are compromised because raw secrets were committed to version control. I would execute an emergency rotation and secure the repository using these steps. 1. Revoke and rotate immediately. Change the compromised database password in the Cloud Console, treating the credential as permanently compromised even after rewriting Git history, since it may have already been cloned, cached, or indexed. 2. Purge Git commit history. Use Git filtering tools to completely rewrite the repository history and remove any trace of the plaintext secret file. 3. Enforce local secret scanning. Integrate a local pre-commit hook such as Git leaks on developer workstations to block commits containing raw keys or base 64 patterns. 4. Migrate to external vaults. Shift your platform architecture to use external secret providers so developers never write raw secret manifests to Git repositories. Pro tip: avoid committing raw base 64 Kubernetes secrets to Git. They are easily decoded and represent a major security risk. Integrate Git leaks in your CI and CD pipelines to scan and reject commits containing secret signatures, and migrate to external operators like external secrets to pull credentials dynamically. Here is bash code demonstrating how to use Git leaks to scan your local repository and prevent accidental secret leaks before committing. Disclaimer: always test code in a non-production environment. This code executes Git leaks locally, scanning all commit histories and uncommitted files in the directory to block dynamic credentials from being pushed.
Production Incident 151. Your organization scales to 800 application pods managed by the External Secrets Operator, ESO. During an auto-scaling surge, the operator's continuous polling loops overwhelm your cloud provider secrets engine like AWS Secrets Manager or HashiCorp Vault, triggering a strict rate limit block 4292 many requests that halts secret synchronization cluster-wide and leaves new pods stuck booting. How do you resolve this?
Answer: this is a secret synchronization scale failure caused by rate limiting. When hundreds of pods scale concurrently, the external secrets operator attempts to verify and pull the target credentials, quickly exceeding the cloud provider's API request quotas. To resolve this, I would modify the secret store configuration to increase the refresh interval for static secrets to reduce polling frequency, which significantly reduces polling traffic and allows the cloud API blocks to cool down. To prevent future rate limits, I would configure local caching inside the operator, use webhook-based push notifications from Vault to trigger syncs only when values actually change, or establish dedicated cloud provider endpoints like AWS Private Link to scale our throughput capacity. Pro tip: default ESO sync intervals are often too aggressive. Scale your refresh interval back for static credentials and group related keys into a single cloud secret payload to minimize the number of outbound API calls, preventing rate-limiting blocks during scaling surges.
Production Incident 152. A security audit reveals that a default service account in an application namespace contains a misconfigured RBAC role that grants the pod creation verb create pods to any system user. An attacker exploits this vulnerability, launching a privileged pod that mounts the host node's root file system, allowing them to escape the container and execute root commands on the host. How do you harden the RBAC policy?
Answer: the privilege escalation occurred because the application was granted unrestricted pod creation and execution permissions. I would resecure the namespace using these steps. 1. Audit active role bindings. Identify all roles and cluster roles bound to application service accounts in the namespace. 2. Enforce least privilege RBAC. Remove wildcard verbs and restrict pod creation permissions to authorized administrative service accounts. 3. Block pod exec exploits. Explicitly deny or restrict access to the pod/exec subresource to stop users from entering container namespaces. 4. Deploy namespace admissions. Implement pod security admissions to reject any incoming pods that attempt to run as privileged or mount host paths. Pro tip: granting unrestricted pod creation can become a privilege escalation path unless strong admission controls and pod security restrictions are enforced. Under permissive configurations like allowing host path mounts or privileged containers, any user with pod creation access can easily escalate to node-level control. Here is Kubernetes configuration demonstrating how to define an RBAC role that restricts pod creation and execution to prevent privilege escalation. Disclaimer: always test code in a non-production environment. This code explicitly defines an empty verb list for the pod exec subresource, preventing user service accounts from escalating privileges by executing commands inside containers.
Production Incident 153. Too many platform engineers and third-party monitoring tools have been granted administrative permissions in your production cluster. A misconfigured cleanup script run by a junior engineer executes a wildcard delete command, wiping out critical production namespaces. How do you recover and implement a least privilege governance model?
Answer: this is a governance failure caused by excessive administrative access. Granting permanent wildcard admin permissions to human users or automated tooling creates a massive blast radius. To recover immediately, I would use our GitOps controller to redeploy the deleted namespaces and restore resources from our backup system. For a permanent fix, I would implement a strict least privilege governance model, removing direct cluster admin bindings for all developers. I would replace permanent admin access with namespace-scoped RBAC roles, and implement a temporal just-in-time JIT access management tool like Teleport or Open Unison to grant temporary cluster admin permissions only during approved, logged incident response windows. Pro tip: permanent cluster admin access is a major operational risk. Use group-based SSO bindings to map developers to restricted, namespace-specific roles, and enforce all production infrastructure changes through pull request approvals in a GitOps repository to completely eliminate manual wildcard deletes.
Production Incident 154. Your database-heavy payment application suddenly loses connection to HashiCorp Vault, causing all active pods to throw 403 forbidden errors. You find that the workloads were authenticating with Vault using standard Kubernetes service account tokens, but because the token time to live TTL expired and the Vault agent sidecar failed to renew the lease, the application lost credential access. How do you restore and automate token renewals?
Answer: the authentication failed because the Vault token lease expired silently without renewal. I would recover the credentials and automate the lifecycle using these steps. 1. Identify renewal failure. Audit the sidecar container and Vault server logs to verify why the active lease renewal failed before executing any service restarts. 2. Restart the Vault sidecars. Force a restart of the application pods to trigger a fresh Kubernetes service account token handshake with Vault once the blocker is understood. 3. Configure Vault Agent Auto-Auth. Update the Vault Agent sidecar configuration on the pods, setting the auto_auth directive to handle token lifecycles. 4. Define token lease renewals. Ensure the Vault agent is configured to write the renewed token to a shared file volume, allowing the application to read the latest credential. Pro tip: standard Kubernetes service account tokens are short-lived. If you integrate with Vault, use the Vault agent sidecar configured with auto_auth and a file-based token sync. This allows the sidecar to automatically manage token renewals in the background, shielding your application from lease expiration drops. Here is HashiCorp Vault Agent configuration, demonstrating how to configure auto-auth with automatic token lease renewal. Disclaimer: always test code in a non-production environment. This code configures the Vault agent to use the local Kubernetes service account token path, allowing the sidecar to handle secure auto-authentication and token lease renewals seamlessly.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 155. Your security policy triggers an automated database password rotation in the cloud. However, immediately after rotation, your application pods begin throwing database connection errors and crashing. You find that although the secret was updated in Kubernetes, the application is still attempting to connect using the old, cached password. How do you resolve this out-of-sync credential state?
Answer: this is a credential synchronization failure. When you mount a Kubernetes secret as an environment variable env, the value is injected at pod startup and remains static throughout the container's lifecycle. Changing the underlying secret does not update the environment variable inside the running container, leading to an out-of-sync state during credential rotation. To resolve this, I would run a rolling restart on the deployment to force new containers to boot and read the updated secret. For a permanent fix, I would configure the application to read the credential from a mounted volume instead, as the kubelet dynamically updates mounted secret files, or deploy an automated reloader controller like Reloader to trigger rolling updates whenever the secret changes. Pro tip: avoid mounting secrets as environment variables if you require zero downtime credential rotation. Mounting secrets as files on a volume allows the kubelet to update them dynamically, or you can leverage open-source reloader operators to automatically trigger rolling updates on dependent pods whenever a secret is rotated.
Production Incident 156. A developer deploys a custom troubleshooting tool but accidentally includes host network, true and privileged, true in the pod spec. An attacker exploits a vulnerability in the tool, escapes the container, and gains full root command access to the underlying host worker node. How do you prevent these privileged deployments?
Answer: the security breach occurred because the API server permitted a pod to run with host-level privileges. I would block these insecure workloads using these steps. 1. Isolate and terminate. Immediately delete the compromised pod from the cluster and quarantine the affected worker node for forensics. 2. Assess pod security standards. Review the namespace configurations to check if pod security admissions are enabled. 3. Enforce restricted policies. Apply strict pod security admission labels to your namespaces, setting the enforce mode to restricted. 4. Validate workload specs. The API server will now automatically validate and reject any new pod deployment requests that violate the restricted pod security standard. Pro tip: default Kubernetes namespaces do not block privileged containers. Always configure pod security admission PSA labels with podsecurity.kubernetes.io/enforce. Restricted on all user namespaces. This forces the API server to reject any insecure pod configurations at the admission gate. Here is Kubernetes configuration, demonstrating how to apply pod security admission labels to a namespace to block privileged and root containers. Disclaimer: always test code in a non-production environment. This code configures the namespace to enforce the restricted security standard, instructing the API server to automatically reject any pods that violate the restricted pod security standard.
Production Incident 157. Your runtime security system Falco triggers high-severity alerts, indicating that a public-facing application container is spawning unexpected terminal shells and downloading a Monero cryptominer binary. The worker node's CPU usage spikes to 100%, starving adjacent workloads. How do you contain this active malware intrusion?
Answer: this is an active container exploit and malware intrusion. To contain the attack immediately, I would quarantine or isolate the compromised workload using existing namespace network policies if active, and terminate the affected pod to let the scheduler rebuild a clean container while we collect forensic logs. Next, I would inspect the application code to identify the vulnerability, like an unpatched log4j dependency that allowed the remote code execution. For a permanent fix, I would configure our container runtimes to use secure isolation engines like gvisor or KEDA containers, which run containers in lightweight sandbox kernels, preventing exploited processes from accessing host-level kernel calls. Pro tip: container runtime security is about fast detection and strict isolation. Do not rely on static image scanning alone. Deploy tools like Falco to detect anomalous process executions in real time, and run untrusted public-facing workloads on sandboxed container runtimes like gvisor to prevent container escape exploits.
Production Incident 158. An attacker exploits a known, high-severity CVE vulnerability in an unpatched base container image running in your cluster, gaining unauthorized access to your billing database. You discover that although the vulnerability was flagged weeks ago, the buggy image was permitted to deploy. How do you block these vulnerable images?
Answer: the security breach occurred because our deployment pipeline lacked automated image validation. I would enforce secure image standards using these steps. 1. Isolate the database path. Immediately rotate all compromised database credentials and terminate any pods running the vulnerable image version. 2. Deploy policy as code. Install a validating admission controller such as Kyverno or OPA Gatekeeper in the cluster. 3. Enforce image tag restrictions. Deploy a strict cluster policy that rejects any pod manifests attempting to use the mutable latest tag. 4. Integrate signature verification. Configure the policy to only allow the deployment of container images that have been cryptographically signed by your pipeline. Pro tip: static image scanning in your CI and CD pipeline can be bypassed if developers manually push images. Always use cosign to sign your images and Kyverno to enforce signature verification at the admission gate, rejecting any unsigned or latest tagged containers before they can boot. Here is Kubernetes configuration, demonstrating how to define a Kyverno cluster policy to block container images using the latest tag. Disclaimer: always test code in a non-production environment. This code configures a pattern match that rejects any image paths ending in the latest tag, forcing deployments to use immutable digests or specific version tags.
Production Incident 159. During peak hours, site-to-site communication between all microservices inside your service mesh like Istio or Linkerd breaks completely. Workloads are throwing mutual TLS-MTLS handshake failures and connection resets on every network request, bringing down the entire platform. You find that the mesh's root CA certificate expired silently. How do you recover?
Answer: this is a service mesh certificate collapse. When the root certificate authority CA certificate used by your service mesh expires, the mutual TLS-MTLS handshakes between the proxy sidecars fail instantly, which blocks all inter-service communication because the proxies can no longer validate each other's identities. To recover immediately, I would configure the service mesh to use a temporary permissive MTLS mode strictly as an emergency-only measure during controlled incident response, which allows services to communicate over plaintext while the security handshakes are down. Next, I would generate a new root CA certificate using Alertmanager, apply it to the mesh control plane, and trigger a rolling restart on all application namespaces to force the sidecars to mount the new certificates before re-enabling strict MTLS mode. Pro tip: service mesh root CA certificates have long life cycles but must be monitored closely. Do not manage mesh CAs manually. Integrate your service mesh control plane directly with an automated certificate manager, like Alertmanager, configured with upstream Vault or Cloud KMS issuers, to handle CA rotations before they expire.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire master vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 160. You deploy Spire to automatically assign secure identities to workloads. However, during a peak scaling event, several database pods fail to start, getting stuck in an infinite initialization loop. The Spire agent logs show that identity issuance is failing because the local agent daemon set is timing out while attempting to authenticate the new node via AWS node at a station. How do you recover the identity pipeline?
Answer: the identity pipeline is blocked because the local Spire agent cannot authenticate the newly scaled node. I would restore the identity issuance using these steps. 1. Audit node at a station policies. Check the backend Spire server configurations to ensure the AWS node at a station policy has sufficient permissions to query EC2 metadata. 2. Verify agent socket paths. SSH into the worker nodes and verify that the Spire agent's local Unix socket path is accessible and mounted correctly by the kubelet. 3. Enforce SPIF ID bindings. Apply a SPIF ID custom resource to explicitly map the target service account to the trusted SPIF trust domain. 4. Restart the agent daemon set. Perform a rolling restart on the Spire agent pods to force them to re-establish secure handshakes with the Spire server. Pro tip: Spire node at a station is highly sensitive to cloud metadata lag. For high-scale EKS clusters, verify that your Spire server's IAM role has the EC2 describe instances permission allowed globally, ensuring the server can quickly validate new nodes as they scale. Here is Kubernetes configuration, demonstrating how to define a SPIF ID resource to automatically assign cryptographic identities to service accounts. Disclaimer: always test code in a non-production environment. This code configures the Spire trust domain and maps the unique SPIF identity path directly to the workload service account, allowing secure inter-pod handshakes.
Production Incident 161. Your cluster's cert manager deployment experiences a sudden failure, and several public-facing ingress gateways lose their secure TLS status. You discover that cert manager is failing to renew certificates due to a combination of Let's Encrypt API rate limits and local webhook failures. How do you resolve this cluster-wide certificate collapse?
Answer: this is a certificate renewal failure caused by rate limits or webhook failures. When Cert Manager encounters continuous DNS validation failures, it will repeatedly retry the Acme challenge, quickly exhausting Let's Encrypt strict API rate limits and triggering a block. To resolve this, I would first check the logs of the Cert Manager webhook pod to verify if local firewalls or systemd resolved conflicts are blocking the DNS01 verification challenge on port 53. Once the webhook's network path is cleared, I would modify our Let's Encrypt cluster issuer, transitioning the staging endpoint to our production profile only after verifying that our Acme challenge integrations succeed without errors, bypassing the active API blocks. Pro tip: Let's Encrypt has tight rate limits on failed validation retries. Always use the Let's Encrypt staging directory in your development clusters to test your issuer and DNS01 challenge integrations, ensuring your production rate limits are preserved for valid live rotations.
Production Incident 162. You deploy a Kyverno policy to enforce container image signature verification. However, during a production deployment, the admission controller begins rejecting all incoming pod manifests with image verification failed errors. You discover that although the pipeline signed the images using cosign, the public key configured inside the Kyverno policy has drifted and does not match the signing key. How do you resolve this release block?
Answer: the deployment is blocked because the Kyverno policy's verification key is out of sync with the pipeline's signing keys. I would align the cryptographic keys using these steps. 1. Audit active policies. Query the active Kyverno cluster policies to locate the specific rules enforcing signature checks. 2. Inspect signing keys. Retrieve the public key used by cosign in the build pipeline to verify the cryptographic signature. 3. Update the policy verification. Edit the Kyverno policy manifest, replacing the outdated public key block with the current valid key. 4. Trigger workload rescheduling. The admission controller will now successfully validate the co-signed signatures, allowing the container deployments to proceed. Pro tip: key rotation can easily paralyze your GitOps releases. Always use keyless signing mode in co-sign and integrate it with OIDC identity providers like Dex or Keycloak to verify the build pipeline's identity dynamically, eliminating the manual overhead of managing static public keys. Here is Kubernetes configuration demonstrating how to define a Kyverno cluster policy to enforce co-sign image signature verification at admission. Disclaimer: always test code in a non-production environment. This code defines the image verification rule, directing the Kyverno admission controller to intercept any containers pulling from our private registry and validate their signatures.
Production Incident 163. A security alert indicates that a compromised container inside your public-facing development namespace is actively scanning port 5432 on a secure production database running in another namespace. You find that because no network isolation was enforced at the cluster layer, east-west traffic is completely open. How do you isolate the namespace traffic?
Answer: this is an east-west namespace traffic leak. By default, Kubernetes networking allows any pod to communicate with any other pod across any namespace. To isolate the database immediately, I would deploy a default deny network policy inside the secure production namespace, which blocks all incoming packets by default. Next, I would add a specific ingress rule that only permits inbound TCP traffic on port 5432 from pods that are explicitly labeled as authorized clients, keeping our internal network traffic restricted and protecting our database from unauthorized lateral scans. Pro tip: treat every namespace as a potential vector of lateral movement. Always implement a default deny all network policy at the namespace level during initial cluster setup, and explicitly declare allowed ingress paths for your microservices to enforce zero trust security.
Production Incident 164. During an external security audit, you discover that your internal Kubernetes dashboard is publicly accessible on the internet without any authentication, exposing your entire cluster configuration to potential attackers. How do you secure the ingress path and restrict access?
Answer: the dashboard is exposed because its ingress resource lacked access control annotations. I would secure the dashboard using these steps. 1. Audit ingress configurations. Query the active ingress resources associated with the dashboard to locate the exposed routing paths. 2. Restrict source IP ranges. Add the whitelist source range annotation to the ingress to restrict access to your corporate VPN subnet. 3. Enforce basic authentication. Configure basic authentication on the ingress, requiring a valid HTTP secret to pass the gateway. 4. Verify private handshakes. Test access from an external, non-VPN IP address to ensure Nginx successfully blocks the connection. Pro tip: never expose administrative interfaces directly to the public internet. Always protect internal consoles like Grafana, ArgoCD, or the Kubernetes dashboard using strict IP whitelisting annotations on your ingress, or restrict access behind an OAuth 2 proxy that integrates with your corporate identity provider. Here is Kubernetes configuration, demonstrating how to configure Nginx ingress annotations to restrict access to internal dashboards based on client IP range. Disclaimer: always test code in a non-production environment. This code configures the whitelist source range annotation, directing Nginx to block any incoming traffic to the internal dashboard, unless the client IP originates from our private subnet.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 165. Your central security logging console suddenly receives a flood of critical runtime alerts from Falco on a specific worker node. The logs show that a public-facing container spawned an unexpected terminal shell, modified /etc/shadow, and attempted to install outbound network scanning tools. How do you contain this active compromise?
Answer: this is an active container compromise. The Falco alerts indicate a successful remote code execution exploit where an attacker has bypassed container boundaries. To contain the compromise immediately, I would use kubectl to delete the affected pod, which terminates the malicious process on the host. Next, I would cordon and drain the node where the exploit occurred to isolate it, allowing our security team to collect forensic container runtime logs. To prevent future exploits, I would enforce strict pod security standards restricted on the namespace to block write access to system directories, and update the application deployment templates to run with read-only root file systems. Pro tip: static image scanning cannot prevent zero-day runtime exploits. Always deploy system call auditing tools like Falco to monitor active container behavior, and configure automated playbooks to automatically terminate or quarantine pods the moment an unauthorized shell execution is detected.
Production Incident 166. During a high-scale deployment storm, the primary Kube API server becomes unresponsive, throwing connection timeouts and slowing down all cluster deployments. You find that the API server is configured to send audit events to an external security logging webhook, but because the webhook backend is overloaded and running in blocking mode, it is stalling the API server's request threads. How do you scale the audit pipeline?
Answer: the control plane is stalled because the audit webhook is configured in blocking mode. I would restore the API server's responsiveness using these steps. 1. Access API server manifests. SSH into the master node and open the API server static pod manifest for editing. 2. Change webhook mode to batch. Update the startup flags, changing the -- audit webhook mode parameter from blocking to batch. 3. Configure batch buffers. Configure the batch maximum weight and buffer size flags to allow the API server to queue events asynchronously. 4. Verify manifest reload. Save the manifest, allowing the kubelet to restart the API server static pod with the new asynchronous batch parameters active. Pro tip: writing audit logs in blocking mode is a major control plane risk. Always configure your API server's -- audit webhook mode to batch with a generous -- audit webhook batch buffer size to ensure that even if your external security logging system goes down, your core API server remains highly responsive. Here is Kubernetes configuration, demonstrating how to configure API server audit webhook parameters in batch mode to prevent control plane deadlocks. Disclaimer: always test code in a non-production environment. This code configures the audit webhook to run in asynchronous batch mode with a dedicated buffer size, ensuring that high-volume security logging sweeps do not block the active request thread of the API server.
Production Incident 167. Your egress network monitoring tools detect a container pod inside your core cluster, attempting to establish a reverse shell connection to an unknown IP address on the public internet. You find that a public dependency library used in the application's base image was compromised a supply chain attack, injecting a backdoor payload during the build process. How do you contain and prevent this?
Answer: this is an active supply chain compromise. The application's base image was modified externally to include a malicious backdoor that attempts to connect to a command and control server. To contain the attack immediately, I would delete the compromised pod and implement an egress network policy to restrict the namespace to internal cluster routing, blocking any outbound traffic to public IPs. To prevent future supply chain attacks, I would update our CI and CD pipeline to generate a software bill of materials SBOM for every build, and configure our validating admission controllers to reject any images that are not explicitly matched against our verified vulnerability scan database. Pro tip: image scanning cannot catch every hidden dependency backdoor. Always restrict outbound internet access from your application namespaces using egress network policies, and ensure your container builds lock down all dependencies to specific, verified version hashes rather than dynamic ranges.
Production Incident 168. The centralized identity provider like Keycloak or DEX used for cluster authentication experiences a complete database outage. Consequently, developers and automated tools cannot authenticate via OIDC and SSO, completely blocking all manual kubectl operations and breaking administrative access during an active production incident. How do you recover cluster access?
Answer: this is an identity provider authentication outage. When OIDC and SSO is down, the API server cannot validate the OpenID Connect tokens presented in developers' kubeconfigs, which locks out all authenticated users. To restore administrative access immediately, I would use our loopback administrative kubeconfig on the master control plane node, which bypasses the OIDC validation and authenticates directly using local certificates. This allows our team to run diagnostic and recovery commands while the identity provider's database is being recovered. Once the identity provider is healthy, I would work with the IAM team to deploy a multi-region HA configuration for Keycloak to prevent future single point of failure outages. Pro tip: never rely exclusively on OIDC and SSO for admin access. Always maintain a secure, highly restricted local certificate-based bootstrap kubeconfig on your control plane nodes, enabling your platform team to bypass external identity failures during critical cluster-wide incidents.
Category 9 Conclusion: Hardening the platform.
Kubernetes security is a continuous, zero-trust hardening effort. As we have seen in these 19 production incidents, securing your platform is not about wrapping applications in bulky policies, but about designing absolute containment by enforcing restricted pod security standards, securing your cryptographic spire identities, and establishing automated image signature validation via Kyverno and cosign. By isolating namespace to namespace traffic, configuring asynchronous audit webhooks, and securing your Vault Auto Auth integrations, you ensure that even if an individual container is compromised, your core operating system and control plane remain completely hardened against lateral movement.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 9 to Category 10.
But even if your cluster is completely secure, your platform cannot scale or function in a vacuum. If security and governance are the shield of your cluster, then your cloud provider's managed platform services are the ground on which it stands. When your cloud controller manager fails, VPC IP allocation is exhausted, or the provider's API rate limits throttle your scaling requests, your hardened cluster collapses from the outside. We must now move from internal security controls to the actual cloud provider interface. Cloud-managed Kubernetes incidents. Let's explore Category 10.
Category 10. Cloud Kubernetes Platform Incidents.
Managed Kubernetes platforms like EKS, GKE, and AKS abstract away the control plane, but they introduce complex integrations with cloud provider APIs, networking, and identity systems. In this category, we dive into the high-stakes failures that occur at the cloud platform boundary, from VPC IP exhaustion and STS rate limiting, to managed node group drift, cloud balancer provisioning failures, and spot instance mass reclaims. We will test your ability to debug provider-level integrations, manage cloud quotas, and keep multi-AZ platforms stable when the cloud environment itself is unstable.
Category 10. Cloud Kubernetes Platform Incidents 169 to 184.
Here are the 16 production incidents of this category covering cloud platform integration failures. Production Incident 169. EKS IAM or AKS Managed Identity or GKE Workload Identity Authentication failures. Production Incident 170. AWS STS rate limiting breaking EKS IAM IRSA authentication. Production Incident 171. VPCCN, IIP exhaustion, no available IPs for new pods. Production Incident 172. Cloud Provider ENI or NIC limit exhaustion preventing pod scheduling. Production Incident 173. Managed Node Group Configuration Drift. Production Incident 174. Cloud Provider Managed Node Image Auto Upgrade Breaking Workloads. Production Incident 175. GKE Autopilot Rejecting Workloads Unexpectedly. Production Incident 176. GKE Node Auto Repair Causing Cascading Evictions. Production Incident 177. Cloud Load Balancer Provisioning Delays/Failures. Production Incident 178. Cloud Provider API Throttling Impacting Cluster Operations. Production Incident 179. Cloud Controller Manager Failure Impacting LB Provisioning. Production Incident 180. Multi-AZ Failover Not Functioning Correctly. Production Incident 181. Spot Instance Mass Reclamation Without Fallback Capacity. Production Incident 182. Cloud NAT Gateway Saturation Under Traffic Spikes. Production Incident 183. Accidental Cluster Deletion Requiring Disaster Recovery. Production Incident 184. Managed Kubernetes Control Plane Upgrade Breaking Workloads. Total 16 production incidents for cloud platforms. Let's start with Production Incident 169.
Production Incident 169. Your newly deployed database backup pods fail to write to your cloud storage bucket, throwing 403 access denied errors. You find that although the target service account has been annotated with the correct IAM role ARN, the pods are failing to assume the role because the trust policy on the cloud IAM role lacks the correct OIDC provider audience mapping. How do you resolve this authentication failure?
Answer: the pods lost write access because the cloud IAM role does not trust the cluster's OIDC provider. I would fix the workload identity mapping using these steps. 1. Extract the OIDC provider URL. Query your EKS or Managed Cluster Metadata to identify the exact OpenID Connect provider URL. 2. Audit the role trust policy. Inspect the AWS IAM roles trust configuration to check if the OIDC provider is registered as a trusted federated entity. 3. Configure service account annotation. Ensure the target service account manifest explicitly matches the role ARN in its annotations. 4. Verify pod token mount. Restart the pods and verify the projected web identity token is mounted correctly and the workload can access it. Pro tip: workload identity configurations are highly sensitive to trust policy mismatches. When using EKS-IRSA, always verify that your IAM roles trust relationship explicitly permits the system:\service account. Namespace: service account name subject, ensuring the cloud provider accepts the token. Here is Kubernetes configuration demonstrating how to annotate a service account with an IAM role ARN to enable workload identity. Disclaimer: always test code in a non-production environment. This code configures the EKS-IRSA annotation, directing the kubelet to dynamically mount the temporary cloud credentials into any pods using this service account.
Production Incident 170. During a massive scaling event where your cluster launches 2,000 new pods simultaneously, all active pods suddenly lose access to AWS resources. You find that the massive rush of pods requesting credentials at the same time has triggered a strict rate limit block on the AWS Security Token Service STS endpoint, breaking IAM roles for service accounts IRSA across the cluster. How do you resolve this?
Answer: this is an AWS STS rate limiting failure. By default, EKS pods authenticate with AWS resources by making outbound calls to the global STS endpoint, which has strict rate limits that can be easily exhausted during massive, parallel scale-ups. To resolve this immediately, I would use our local administrative credentials to manually pause the autoscaler and prevent new pods from spawning. Next, I would modify the deployment specs to inject the AWS STS regional endpoints equals regional environment variable into the pod templates, directing the containers to query their local, regional STS endpoints instead of the global endpoint, which distributes requests across regional endpoints and can significantly reduce contention on the global endpoint, unblocking credential validation. Pro tip: outbound global STS lookups are a common bottleneck. When managing EKS clusters running at scale, always configure the AWS STS regional endpoints environment variable to default to regional, which reduces latency and distributes the API load across AWS's regional control planes.
Production Incident 171. During an auto-scaling surge, several new pods remain stuck in a pending state indefinitely. Running diagnostics reveals that the pods are failing with failed create pod sandbox errors because the AWS VPCC NI has exhausted all available IP addresses on the node's local subnet, blocking the container network interface from allocating IPs. How do you resolve this IP exhaustion?
Answer: pods cannot start because the node's local subnet has run out of available IP addresses. I would resolve the IP exhaustion using these steps. 1. Evaluate base capacity. Audit the VPC subnet allocation metrics in the Cloud Console to check if we can expand subnet capacity or optimize existing IP utilization. 2. Enable prefix delegation. Consider enabling prefix delegation on the CNI to allocate entire sitter blocks per ENI slot before adopting complex custom networks. 3. Configure VPC CNI custom networking. If subnets are completely constrained, edit the VPC CNI config map to enable custom networking, directing the CNI to allocate IPs from secondary subnets. 4. Define ENI configs. Create ENI config custom resources matching your availability zones to map the new subnet interfaces to the nodes. Pro tip: default VPC CNI configurations allocate pod IPs from the same subnet as the host nodes, which quickly exhausts standard subnets. Always enable custom networking in your VPC CNI settings, allowing the cluster to allocate pod IPs from secondary, non-routable sitter ranges like 100.64.0.0/10 to protect your primary subnets. Here is AWS VPC CNI configuration, demonstrating how to enable custom networking and define secondary subnet mappings. Disclaimer: always test code in a non-production environment. This code defines the ENI config custom resource, directing the VPC CNI to provision elastic network interfaces in the specified secondary subnet for nodes running in the US East 1A zone.
Production Incident 172. Your EKS cluster has plenty of aggregate CPU and memory headroom, but new pods are failing to schedule on small instance types like M5.large. You find that the nodes have hit their physical limit for elastic network interfaces, ENIs, blocking the CNI from attaching more IP addresses to the host, even though the nodes are mostly idle. How do you resolve this limit exhaustion?
Answer: this is an ENI limit exhaustion issue. In AWS EKS, every instance type has a hard-coded maximum limit of physical network interfaces ENIs and IP addresses it can support. If you run many small pods, you will exhaust these IP slots long before you run out of CPU or RAM. To resolve this, I would update our VPC CNI configuration to enable prefix delegation. This changes the CNI behavior, allowing it to allocate entire /28 sitter blocks prefixes of 16 IPs to each ENI slot instead of individual IP addresses, substantially increasing the number of pod IPs available per ENI and unblocking the scheduling path on smaller node sizes. Pro tip: small node sizes are easily bottlenecked by ENI limits. When building EKS clusters, always enable prefix delegation in your VPC CNI daemon set and adjust the warm_prefix_target settings to ensure the CNI pre allocates enough IP blocks without exhausting your VPC subnet pools.
Production Incident 173. An administrator manually updates a security group directly in the AWS console to debug a database connection. However, during the next automated scale-up, your cluster auto-scaling engine fails because the manual changes created a configuration drift that conflicts with your Terraform code, causing new nodes to boot with mismatched security rules that prevent them from joining the cluster. How do you restore consistency?
Answer: this is an infrastructure as code drift failure. When manual changes are made in the Cloud Console, they bypass the version-controlled state of your Terraform files, leading to silent mismatches that corrupt automated node provisioning during scaling events. To resolve this, I would immediately run a Terraform plan to identify the drifted parameters and apply the appropriate Terraform changes after reviewing the plan. I would then update our Cloud IAM policies to enforce strict write blocks on production node groups, forcing all future configuration changes to go through approved pull requests and automated CI and CD runs. Pro tip: never allow manual modifications in production Cloud Consoles. Always enforce read-only permissions for human users, and use GitOps pipelines to apply infrastructure changes. Ensuring your live cluster configuration is always 100% aligned with your Git repositories.
Production Incident 174. Your cloud provider executes an automatic node image security patch across your managed node group. Immediately after the patch, several legacy, high-volume database pods begin crashing because the updated container runtime containerd has strict systemd cgroup configurations that reject legacy container schemas. How do you recover and block automated upgrades?
Answer: this is a managed platform upgrade failure. In environments where automatic node image upgrades are enabled, these unannounced updates can introduce runtime or kernel version changes that break older, non-compliant container specs. To recover immediately, I would modify our node group settings to temporarily freeze the auto upgrade window and manually scale up a legacy node group version to restore database availability. For a permanent fix, I would configure our node group upgrade settings to utilize custom AMEIs, allowing our platform team to test, validate, and roll out node image patches through controlled, scheduled maintenance windows rather than relying on automatic provider pushes. Pro tip: relying on automatic cloud provider node upgrades is a high-risk practice for enterprise clusters. Always manage your node images via custom AMEIs or pinned version templates, and validate updates in a staging environment to ensure runtime compatibility before upgrading production compute pools.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 175. You attempt to deploy a custom security monitoring agent in a GKE autopilot cluster, but the deployment fails, throwing forbidden validation errors. You find that GKE autopilot is rejecting the pod spec because the agent's daemon set attempts to run with privileged host namespaces and custom kernel capabilities that are blocked by autopilot's strict security boundaries. How do you resolve this?
Answer: this is a managed platform security boundary failure. GKE Autopilot abstracts away node management and enforces a highly restricted, read-only security profile on all workloads to protect the shared infrastructure. Any daemon set attempting to request raw host namespaces or custom kernel capabilities will be rejected at the admission gate. To resolve this, I would modify the security agent's manifest, removing the privileged, true and host PID flags, and aligning its capabilities with the allowed platform defaults. If the security tool absolutely requires raw kernel access, we must evaluate whether the workload belongs on a standard cluster or dedicated node pool if its requirements exceed autopilot constraints. Pro tip: GKE Autopilot is designed to enforce strict security baselines automatically. Before selecting autopilot for your cluster, audit your third-party security, logging, and CNI daemon sets to ensure they do not require raw host-level access. Otherwise, they will be blocked by the platform's security policies.
Production Incident 176. A transient network drop causes a GKE worker node to lose connection to the master control plane briefly. GKE's automated auto repair engine misinterprets this as a hardware failure, immediately marking the node as dead and triggering a forceful restart that evicts all running workloads, taking down a critical payment gateway service. How do you configure auto repair safeguards?
Answer: this is an automated node recovery failure. While GKE's auto repair system is useful for replacing dead nodes, transient network drops can trigger false positives, leading to unnecessary evictions and service downtime. To recover immediately, I would verify the network status of the remaining nodes to ensure the partition has resolved. To prevent future false positive evictions, I would implement robust pod disruption budgets (PDBs) across our microservices, forcing GKE's eviction API to wait and respect our minimum availability limits. I would also work with our cloud team to review available auto repair configuration options and engage the cloud provider where platform behavior requires tuning before executing any node recycles. Pro tip: auto repair systems can easily create cascading evictions if not guarded. Always protect your services with strict pod disruption budgets (PDBs) to ensure that even during automated cloud provider node repairs, the platform is physically blocked from evicting more pods than your service SLAs allow.
Production Incident 177. You deploy a new public-facing API service, but the load balancer service remains stuck in a pending state indefinitely. Running diagnostics shows that the AWS load balancer controller is failing to provision the physical network balancer because the cluster subnets are missing the required public discoverability tags, blocking the AWS load balancer controller. How do you resolve this provisioning block?
Answer: the load balancer service is stuck because the AWS load balancer controller cannot find subnets with the required AWS discovery tags. I would resolve the provisioning block using these steps. 1. Audit subnet tags. Check the VPC subnet configuration in the AWS console to verify if the cloud discovery tags are present. 2. Enforce public discovery tags. Add the kubernetes.io/role/l one tag to your public subnets so the AWS load balancer controller can locate them. 3. Enforce private discovery tags. Add the kubernetes.io/role/internal-elb one tag to your private subnets for internal load balancers. 4. Verify controller sync. The AWS load balancer controller will automatically detect the updated tags and successfully provision the physical load balancer. Pro tip: cloud controller managers rely on specific subnet tags to automate load balancer provisioning. When deploying EKS clusters via Terraform, always ensure your public and private subnets are explicitly tagged with kubernetes.io/role/elb to prevent service creations from hanging indefinitely. Here is Kubernetes configuration, demonstrating how to configure annotations to specify the AWS load balancer type in a service manifest. Disclaimer: always test code in a non-production environment. This code configures the service annotations, directing the AWS load balancer controller to provision an external network load balancer using IPVS target mapping.
Production Incident 178. During a high-scale deployment storm, your cluster autoscaler and CSI storage drivers stop working entirely. The logs are flooded with rate limit exceeded errors from the cloud provider, indicating that the cluster service accounts have made too many parallel API calls, causing the cloud provider to throttle all cluster-wide infrastructure operations. How do you mitigate the throttling?
Answer: this is a cloud provider API rate limiting failure. When your autoscalers, ingress controllers, and storage drivers rapidly query the cloud control plane, for example EC2 describe instances, they can quickly exhaust your account's regional API rate limits, causing the cloud provider to drop subsequent requests. To mitigate this immediately, I would manually pause non-essential background automated runs and scale down aggressive controllers. For a permanent fix, I would adjust the cluster autoscaler settings, tuning the polling intervals to balance responsiveness and API consumption, and work with our AWS or GCPT AM to request a permanent increase in our API rate limiting quotas. Pro tip: cloud provider API limits are a common bottleneck in massive clusters. Always configure your dynamic controllers like cluster autoscaler or external DNS to tune polling intervals to balance responsiveness and API consumption, preventing redundant API queries from triggering regional rate limiting blocks during peak scaling events.
Production Incident 179. A critical platform failure occurs. Your cluster's Cloud Controller Manager CCM pod crashes on startup, and all service load balancer provisions and node IP synchronizations halt globally. The logs show the CCM is failing to start due to a metadata authentication mismatch with the newly upgraded Cloud API. How do you recover the controller?
Answer: this is a Cloud Controller Manager configuration failure. The CCM is responsible for coordinating node allocations and provisioning physical cloud load balancers. If a managed platform upgrade introduces a change in the cloud API schema, older CCM versions will fail to authenticate and crash. To recover immediately, I would inspect the controller logs and validate that our cloud credentials or IAM permissions are correctly configured, as an auth mismatch can be resolved without a rollback. If an unresolvable version incompatibility is confirmed, I would then roll back the CCM deployment to a stable, compatible version that matches the cloud provider's API expectations before re-enabling automatic syncs. Pro tip: the Cloud Controller Manager is a critical link between Kubernetes and your cloud provider. Always decouple your CCM upgrades from raw node updates and verify that your CCM version strictly matches the Kubernetes minor version release guidelines to prevent silent authentication crashes during upgrades.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip: whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 180. A physical cloud data center experiences a total power outage, taking down all nodes in Availability Zone US East 1A. Your high-priority database stateful set attempts to failover to US East 1B, but the new pod remains stuck pending indefinitely. You find that the underlying persistent volume is bound to US East 1A, preventing the database from booting on the new node. How do you resolve this stateful zone block?
Answer: this is a multi-AZ stateful failover mismatch. Standard cloud block storage like AWS EBS is physically bound to a single availability zone. If your stateful set pod is rescheduled in a different zone after an outage, it cannot mount its existing volume, leaving the database stuck pending. To resolve this immediately during an active incident, I would execute a database-level failover to a replica running in a healthy zone and promote it to primary. For a long-term fix, I would evaluate an appropriate multi-zone storage solution for your workload such as AWS EFS or Portworx as examples that natively replicates data across zones, or configure our storage classes to use topology-aware weight for consumer parameters. Pro tip: block storage has physical zone limits. If you run critical stateful workloads in cloud environments, always run them as a clustered database like PostgreSQL, with replication with active replicas, distributed across multiple availability zones, ensuring you can execute a logical database failover without waiting on physical volume migrations.
Production Incident 181. AWS triggers a massive spot instance reclamation event, terminating all spot-backed nodes in US East 1A during peak hours. Because your Karpenter node pools are configured to only use spot instances, the cluster is starved of compute, and the Autoscaler cannot find any available spot capacity to launch replacements, taking down critical APIs. How do you restore fallback capacity?
Answer: the cluster is starved of compute because the spot instance pool is completely exhausted in the zone. I would configure a diversified fallback strategy using these steps. 1. Audit node pool configurations. Open the Karpenter node pool spec to check if the capacity type requirements are restricted exclusively to spot. 2. Enforce capacity diversification. Update the requirements block in the node pool to allow both spot and on-demand capacity types. 3. Configure on-demand fallback. The auto-scaling engine will now automatically fall back to provisioning on-demand nodes if spot instances are unavailable. 4. Verify node provisioning. Monitor Karpenter's logs to ensure new on-demand nodes successfully boot and join the cluster to restore API availability. Pro tip: running 100% of your workloads on spot nodes is an anti-pattern. Always configure your Karpenter node pool specifications to include both spot and on-demand capacity types as fallbacks, allowing the engine to automatically provision reliable on-demand VMs when spot markets are exhausted. Here is Karpenter configuration, demonstrating how to configure capacity type requirements in a node pool to allow automatic on-demand fallback. Disclaimer: always test code in a non-production environment. This code configures Karpenter's capacity requirements, allowing the engine to automatically fall back to provisioning on-demand nodes if the spot instance pool is exhausted during cloud provider reclamation events.
Production Incident 182. During a sudden morning traffic spike, outbound connection requests from your application pods to external third-party payment gateways begin dropping intermittently. You find that the cloud provider's NAT gateway is saturated, dropping network packets because the outbound traffic volume has exceeded the gateway's processing bandwidth limits. How do you resolve this?
Answer: this is a cloud NAT gateway saturation issue. While cloud-managed NAT gateways handle high traffic, they have hard-coded limits on bandwidth and connections. If your cluster-wide outbound traffic spikes past these limits, the gateway will drop packets, causing connection timeouts. To resolve this immediately, I would deploy additional NAT gateways and split our subnets to distribute the outbound routing load across multiple gateways. For a long-term fix, I would implement VPC endpoints private link inside our subnets directing high-volume cloud service traffic such as SQS or S3 queries to route internally rather than traversing the NAT gateway, significantly reducing NAT gateway traffic. Pro tip: NAT gateways are a common, expensive network bottleneck. Always configure private VPC endpoints for high-throughput cloud services like S3 or ECR to ensure traffic routes internally over the private network, shielding your NAT gateway from saturation during scaling surges.
Production Incident 183. An automated Terraform cleanup script run with bad credentials accidentally deletes your primary production EKS cluster. The control plane, namespaces, and active configurations are wiped out instantly, leaving only your persistent cloud database backups intact. How do you coordinate the disaster recovery?
Answer: the cluster was deleted and all control plane configurations are lost. I would coordinate the recovery and restore services using these steps. 1. Rebuild the base infrastructure. Use Terraform to immediately redeploy the core EKS cluster and node group infrastructure. 2. Install the backup controller. Ensure your backup tooling such as Velero is available and fully configured to connect to our backup bucket before initiating any restore. 3. Trigger the Velero restore. Run a restore command from our latest verified backup, verifying the restored state with our live resources. 4. Verify service routing. The GitOps controller will automatically sync and reconcile any remaining infrastructure drift, restoring active user traffic. Pro tip: do not rely solely on GitOps to recover from a cluster deletion. Stateful resources like PVs and metadata are not preserved in Git. Always run regular Velero backups and configure S3 bucket versioning to ensure you can restore volume snapshots and metadata states during emergency cluster recoveries. Here is Velero CLI code demonstrating how to execute a cluster-wide restore from the latest verified backup. Disclaimer: always test code in a non-production environment. This code triggers the Velero restore engine, downloading the cluster metadata and recreating all namespaces, configurations, and persistent volume links from the backup repository.
Production Incident 184. After upgrading your managed Kubernetes control plane to a new minor version such as EKS 1.29 to 1.30, several application deployments fail to start up, throwing API version not found errors. You discover that the upgraded control plane has removed support for deprecated API groups, blocking your GitOps pipelines from applying legacy manifests. How do you resolve this upgrade block?
Answer: this is an API deprecation upgrade failure. When managed Kubernetes platforms upgrade, they enforce the removal of deprecated API groups slated for that minor release. Any deployment templates using legacy versions will be rejected at the admission gate. To resolve this immediately, I would use an administrative loopback kubeconfig to check the active API schemas, manually locate the failing manifest templates in Git, and update their API version values to the current supported schemas. Once the manifests are updated, the GitOps controller will successfully sync the resources, restoring deployment pipelines. Pro tip: managed upgrades should always be pre-flight checked. Always run tools like Pluto or Kube, no trouble Kubent in your CI and CD pipelines, to scan active Helm charts and manifest files for deprecated API groups before you upgrade the cluster control plane, avoiding release lockouts.
Category 10 Conclusion. Mastering Cloud Kubernetes Platforms.
Managed Kubernetes platforms like EKS, GKE, and AKS simplify cluster administration, but they introduce complex integrations with cloud provider APIs, networking, and identity systems. As we have seen in these 16 incidents, managing the cloud platform boundary is not just about using default templates. It is about managing resource quotas and provider-level limits. A true platform engineer does not solve a scale-up failure by blindly triggering untested cloud upgrades or running unthrottled targeted Terraform updates. Instead, they implement robust VPC CNI custom networking, utilize OIDC workload identities, and define strict Karpenter capacity type fallbacks. By securing your cloud integrations, you build a resilient foundation that can absorb massive regional disruptions.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 10 to Category 11.
But even the most stable, cloud-integrated platform cannot protect your applications from their own internal traffic patterns. If cloud platform integrations are the ground on which your cluster stands, then service mesh and advanced routing are the traffic lights that guide microservice communication. When sidecar injection webhooks timeout, Envoy proxies crash, or retry policies trigger cascading back-end storms. Your zero-trust network becomes a bottleneck. We must now move from external cloud integrations to the dynamic routing of the service mesh. Service mesh and advanced traffic incidents. Let's explore Category 11.
Category 11. Service mesh and advanced traffic incidents.
Service meshes allow you to enforce mutual TLS, circuit breaking, and progressive traffic routing across your microservices, but they introduce significant operational overhead. In this category, we dive into the high-stakes failures that occur when your service mesh control plane or proxy sidecars break under load, from sidecar webhook timeouts and Envoy proxy crashes, to XDS synchronization delays, misconfigured circuit breakers, and retry storms. We will test your ability to scope down configuration pushes, tune connection pools, and design resilient traffic routing that protects your back-end database from cascading collapses.
Category 11. Service mesh and advanced traffic incidents 185 to 191.
Here are the 7 production incidents covering service mesh and advanced traffic failures. Production Incident 185. Istio sidecar injection failures webhook timeouts. Production Incident 186. Envoy proxy crash looping across services. Production Incident 187. MTLS handshake failures between microservices. Production Incident 188. Service mesh control plane overload Istio D and XDS sync delays introducing high routing latency. Production Incident 189. Linkerd certificate expiration outages. Production Incident 190. Circuit breaker misconfiguration dropping healthy traffic. Production Incident 191. Retry policies creating cascading back-end outages.
Production Incident 185. During a massive scaling event, your newly created application pods fail to start, getting stuck in a create container config error state. You find that the mutating admission webhook for Istio sidecar injection Istio sidecar injector is overloaded and timing out under the high API write volume, blocking the container creation process. How do you resolve this injection deadlock?
Answer: the pods are failing to start because the sidecar injection webhook is timing out and blocking container admission. I would unblock the deployment using these steps. 1. Audit webhook logs. Check the logs of the Istio D or Istio sidecar injector pods to identify specific timeout or handshake errors. 2. Increase webhook timeout. Update the mutating webhook configuration to increase the timeout limit, giving the injector more time to evaluate the pod spec. 3. Exempt critical namespaces. Ensure that system namespaces are explicitly excluded from the webhook rules to prevent critical daemon sets from getting blocked. 4. Scale the injector deployment. Increase the replica count of your Istio D deployment to handle more concurrent mutation requests. Pro tip: mutating admission webhooks can easily block cluster deployments if they time out. For high-scale service meshes, tune your mutating webhook configuration to use a short timeout limit, and ensure your webhook deployment is scaled horizontally across multiple availability zones. Here is Kubernetes configuration demonstrating how to configure timeout seconds in a mutating webhook configuration to prevent sidecar injection hangs. Disclaimer: always test code in a non-production environment. This code configures the timeout limit and failure policy for the mutating webhook, ensuring that if the sidecar injector is slow or unresponsive, the API server drops the request quickly instead of hanging.
Production Incident 186. Following a major update to your service mesh configurations, several Envoy proxy sidecars across your cluster enter a continuous crash loop back-off state. The application containers are healthy, but they cannot route traffic because the sidecars are crashing due to a dynamic configuration mismatch. How do you troubleshoot and fix the crash loop?
Answer: this is an Envoy proxy configuration crash. Envoy proxies rely on dynamic configuration XDS updates from the service mesh control plane such as Istio D to build their internal routing tables. If you push an invalid custom routing rule, or if the sidecar receives an out-of-spec certificate, the Envoy process will bail out and crash. To resolve this, I would check the logs of the crashing Envoy container to identify the specific parsing or configuration error. I would then use the Istio Control Analyze or Istio Control Proxy status diagnostic tools to verify sync alignment and pinpoint the bad configuration, allowing us to roll back the offending virtual service or gateway resource in Git. Pro tip: Envoy proxies are designed to fail closed during critical configuration errors. Always use validation webhooks like Istio service validator to catch syntax or schema errors before they are applied, and use Istio control to verify the synchronization status of your sidecars before initiating a rolling update.
Production Incident 187. Microservices inside your service mesh suddenly lose connection to each other, throwing cryptographic handshake failures and connection resets. You discover their node clock drift has invalidated the local sidecar certificates issued by the mesh CA, breaking mutual TLS-MTLS validation. How do you recover and allow traffic to flow?
Answer: the MTLS handshakes are failing because the local sidecar certificates are out of sync with the mesh CA. I would restore the communication path using these steps. 1. Audit mesh certificates. Check the logs of the Istio pod or your cert manager issuer to verify if the certificate authority is healthy. 2. Configure permissive mode. Update the peer authentication configuration to set the MTLS mode to permissive as an emergency-only workaround. 3. Verify plaintext fallback. This allows the proxies to accept both plaintext and secure MTLS connections, immediately restoring traffic flow. 4. Synchronize node clocks. Force sync the node's host clock using cronid, then restart the application pods to regenerate valid sidecar certificates. Pro tip: permissive MTLS mode is a powerful emergency-only tool. If your root certificate rotates or if clock drift breaks handshakes, switching to permissive mode keeps your traffic alive while you rebuild the certificate trust chains, avoiding complete platform downtime. Here is Kubernetes configuration demonstrating how to use peer authentication to configure permissive MTLS to recover service mesh communications during a certificate outage. Disclaimer: always test code in a non-production environment. This code configures the peer authentication mode to permissive, allowing services to accept both plaintext and MTLS handshakes during emergency recovery windows.
Production Incident 188. As your cluster scales to hundreds of namespaces, the central service mesh controller Istio CPU usage spikes to 100%. Envoy proxies begin experiencing massive delays in receiving routing updates, causing traffic to be routed to dead pods or stale endpoints and introducing high routing latency. How do you optimize the control plane?
Answer: the control plane is overloaded because it is trying to push the entire cluster's service configuration to every single Envoy sidecar. I would optimize the sync paths using these steps. 1. Audit controller latency. Query the Istio metrics to check the active XDS sync latency and the memory footprint of the controller. 2. Deploy an Istio sidecar resource. Create an Istio sidecar resource to restrict the scope of configuration pushes to specific namespaces. 3. Bypass global configuration. This directs Istio to only push routing updates that are actually relevant to the local namespace's workloads. 4. Verify controller recovery. The CPU usage on Istio will immediately drop, and XDS sync times will return to sub-second speeds. Pro tip: by default, every Envoy sidecar receives the configuration for times every time service in the cluster, which is highly memory-intensive. Always deploy an Istio sidecar resource in each namespace to restrict the egress scope, keeping your control plane fast and lightweight. Here is Kubernetes configuration demonstrating how to use an Istio sidecar resource to restrict the scope of dynamic configuration, pushes to specific namespaces. Disclaimer: always test code in a non-production environment. This code configures the sidecar egress listener scope, directing the control plane to only push XDS routing updates for services running inside the current namespace or Istio system, reducing memory overhead.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 189. Your Linkerd service mesh suddenly experiences a complete outage, and all pod-to-pod communication is blocked with handshake failures. You find that Linkerd's Identity Issuer Certificate has expired silently, rendering the proxies unable to validate internal identities. How do you recover the trust chain?
Answer: this is a service mesh certificate expiration outage. Linkerd's identity model relies on a local trust anchor and an identity issuer certificate to sign the MTLS credentials for each sidecar. If the issuer certificate expires, no proxy can authorize connection requests, taking down the entire service mesh. To resolve this, I would use our local administrative credentials to manually generate a new certificate chain. Apply the secrets to the Linkerd namespace and perform a rolling restart on all application workloads to force the proxies to mount the new certificates. To prevent a recurrence, I would integrate Cert Manager to automatically handle Linkerd certificate rotation before they expire. Pro tip: managing service mesh certificates manually is a common failure point. Always configure Cert Manager to manage Linkerd's identity certificates, and implement Prometheus alerts targeting the Linkerd_identity_cert_expiration_ seconds metric to catch rotation failures before they disrupt cluster traffic.
Production Incident 190. You configure a circuit breaker on an Istio destination rule to protect your payment backend from being overloaded. However, during a normal morning traffic burst, the limits are tripped too early, and healthy customer requests are dropped with immediate 503 service unavailable errors. How do you resolve and optimize the circuit breaker?
Answer: the circuit breaker is dropping healthy traffic because its threshold parameters are configured too aggressively for our peak loads. I would optimize the destination rules using these steps. 1. Audit outlier metrics. Check Prometheus metrics for your service mesh to verify if the 503 errors are caused by active circuit breaker evictions. 2. Tuning outlier detection. Edit the destination rule configuration to increase the maximum connections and pending requests limits. 3. Soften eviction rules. Adjust the outlier detection settings to only evict a pod if it experiences consecutive 500-level errors rather than single connection drops. 4. Verify traffic flow. Apply the updated manifest, ensuring the circuit breaker is tuned to allow peak bursts while still protecting the backend from database overloads. Pro tip: circuit breakers must be tuned based on observed peak load. Instead of using arbitrary low limits, configure outlier detection with a high consecutive 5xx errors count, and use connection pool limits that are aligned with your backend database connection pools to prevent premature traffic drops. Here is Kubernetes configuration, demonstrating how to use an Istio destination rule to configure resilient circuit breaking with outlier detection. Disclaimer: always test code in a non-production environment. This code configures outlier detection on the destination rule, telling Envoy to temporarily evict a specific backend pod if it returns 5 consecutive errors, rather than tripping the circuit breaker globally.
Production Incident 191. A minor database slowdown occurs, causing your payment backend to respond slowly to API requests. Downstream microservices begin aggressively retrying their failed requests using standard retry policies, triggering a massive retry storm that completely saturates the database connection pool, turning a minor slowdown into a total platform outage. How do you design resilient retries?
Answer: this is a retry storm cascading outage. When downstream clients implement simple retry loops without backoff or jitter, a transient backend slowdown will trigger a surge of redundant traffic that quickly overwhelms the already struggling database. To resolve the active outage immediately, I would use our service mesh to deploy a temporary virtual service rule that caps the maximum retry count to 0 for non-essential traffic, giving the database breathing room to recover. To prevent future retry storms, I would configure our service mesh policies to use exponential backoff with random jitter, and implement a retry budget that limits retry traffic to a maximum of 10% of total request volume. Pro tip: avoid using flat retry policies. Always configure your retry loops with exponential backoff and randomized jitter to spread out the request burden during backend slowdowns, and use circuit breakers or retry budgets to ensure that retries do not exacerbate an active database outage.
Category 11 Conclusion. Mastering service meshes and traffic.
Service meshes provide advanced traffic controls, but they introduce complex failure modes. As we have seen in these 7 incidents, managing traffic is not just about writing virtual service routing paths. It is about managing proxy sidecar resource footprints and control plane communication loops. A true platform engineer does not solve a mesh outage by blindly setting permissive MTLS permanently or configuring unoptimized retry storms. Instead, they implement strict sidecar egress configurations to restrict XDS push scopes, configure resilient circuit breakers with robust outlier detection, and enforce exponential backoffs with randomized jitter. By hardening your transit paths, you ensure your platform maintains low latency and remains resilient during downstream slowdowns.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 11 to Category 12.
But even if your traffic routing and service mesh are perfectly resilient, your platform is only as fast and secure as the tools that build and deploy it. If the service mesh represents the circulatory system of your cluster, then your CI and CD pipelines, internal developer portals, and virtual clusters are the factories that manufacture the workloads. When build runners freeze, Docker and Docker containers experience storage failures, or virtual cluster DNS loops exhaust node CPU, the platform's supply chain breaks. We must now move from transit routing to the developer enablement layer. Platform tooling, IDP and CI and CD incidents. Let's explore Category 12.
Category 12. Platform tooling, internal developer platforms IDP and CI and CD incidents.
Platform tooling and developer portals enable self-service velocity, but they introduce unique engineering challenges and massive security risks. In this category, we dive into the high-stakes failures that occur in your build and deployment infrastructure, from dynamic runner pod pending loops in Docker and Docker MTU mismatches, to virtual cluster core DNS routing loops, Crossplane API throttling, and insecure golden templates. We will test your ability to protect the developer supply chain, enforce strict RBAC boundaries on your deployment engines, and keep self-service pipelines stable under peak engineering demands.
Category 12. Platform tooling, IDP and CI and CD incidents 192 to 201.
Here are the 10 production incidents covering platform tooling and developer enablement failures. Production Incident 192. Jenkins or GitHub Actions runner pods stuck in pending state or failing intermittently. Production Incident 193. Docker and Docker D and DMTU or storage failures inside CI pipelines. Production Incident 194. Artifact Registry outage blocking all cluster deployments. Production Incident 195. vCluster Virtual Cluster Core DNS forwarding loop spiking node CPU to 100%. Production Incident 196. Crossplane API provider rapidly reconciling cloud resources and getting rate limited by AWS or GCP APIs. Production Incident 197. HashiCorp Vault Agent Sidecar Token Expiration or Renewal Failures blocking app startup. Production Incident 198. ArgoCD or Flux RBAC misconfiguration exposing production access. Production Incident 199. Backstage or internal developer portal unavailable during deployments. Production Incident 200. Internal platform APIs returning stale or bad data to platform controllers. Production Incident 201. Golden templates deploying insecure configurations platform-wide.
Production Incident 192. During a high-frequency engineering release window, several dynamic CI runner pods get stuck in a pending state or fail intermittently. You find that the ephemeral nodes are exhausted because the runner pods are configured without resource limits, allowing a few heavy build jobs to starve the node pools and prevent new runners from scheduling. How do you stabilize the runner queue?
Answer: the runner queue is stalled because dynamic build pods are starving the node pools of resources. I would stabilize the scheduling queue using these steps. 1. Enforce resource quotas. Apply strict resource limits to the specific namespaces where dynamic CI runners are launched. 2. Deploy dedicated node pools. Configure the runner pods to use node affinity to force them to run exclusively on dedicated, isolated CI instances. 3. Implement automatic pod eviction. Set active runtime deadlines on the pods to ensure hung or zombie builds are automatically killed. 4. Verify queue recovery. The scheduler will now distribute the runner pods evenly, unblocking the queue and maintaining stable build execution. Pro tip: dynamic build runners are classic resource hogs. To protect your core cluster, always run dynamic CI executors in a dedicated, isolated node pool, and enforce strict namespace quotas and default container limits to prevent a single bad build from taking down adjacent runner instances. Here is Kubernetes configuration, demonstrating how to define a pod template with resource limits for dynamic CI runner pods. Disclaimer: always test code in a non-production environment. This code configures the active deadline seconds parameter, instructing the API server to automatically terminate the pod if the build job hangs or runs for more than an hour.
Production Incident 193. Your automated container image build pipelines begin failing intermittently during the image push phase. You find that the Docker in Docker din daemon inside the runner pod is dropping network packets, because the inner Docker daemon's MTU is set to a standard 1500, which is larger than your cluster's virtual CNI tunnel MTU, causing silent packet drops on large layer uploads. How do you resolve this?
Answer: the image uploads are failing because the inner Docker daemon's MTU is larger than the underlying CNI network tunnel. I would resolve the packet drops using these steps. 1. Identify CNI MTU size. Audit the active CNI configuration to find the exact MTU size of the node's virtual network interface. 2. Enforce daemon MTU limits. Create a custom config map containing a daemon.json file that explicitly scales down the MTU of the inner Docker daemon. 3. Mount the configuration. Mount the config map into the dnd container/etc/docker directory in the runner template. 4. Verify image uploads. The inner Docker daemon will now successfully handshake with the registry, completing large image pushes without packet drops. Pro tip: Docker and Docker daemons do not automatically inherit the host or CNI network limits. To prevent packet fragmentation and timeouts during large layer pushes, always configure the dnd daemon.json with an MTU size that is slightly smaller than your CNI interface MTU. Here is Kubernetes configuration, demonstrating how to configure the inner Docker daemon's MTU size, using a mounted daemon.json in a dnd container. Disclaimer: always test code in a non-production environment. This code configures the inner Docker daemon's MTU limit to 1400 and sets the storage driver to overlay 2, ensuring network packets and image layers are processed efficiently within the container.
Production Incident 194. Your enterprise private artifact registry, such as Harbor or Artifactory, experiences a major database outage, going completely offline. Immediately, all automated cluster deployments across your development and production environments freeze with image pull backoff errors as nodes fail to pull application images. How do you recover and protect the platform?
Answer: this is an artifact registry dependency failure. When your central container registry goes offline, any rolling updates, node auto-scaling events, or pod reschedules will freeze immediately because the local kubelet cannot pull the required images. To recover immediately, I would put a temporary freeze on our automated deployment pipelines to prevent further rollout hangs. For a long-term fix, I would configure a local pull-through cache proxy registry like a registry mirror inside the cluster network, or use a cloud-native replicated registry. This ensures the nodes can continue pulling cached base images locally even if the central enterprise registry is completely offline. Pro tip: never let your production clusters rely entirely on a single, non-replicated artifact registry. Always configure a local pull through cache, or use geo-replicated container registries across multiple cloud regions to protect your cluster's deployment availability from registry outages.
Production Incident 195. You use Virtual Cluster's vCluster to allow developers to self-service their own environments. However, a developer accidentally configures an infinite DNS forwarding loop, causing DNS queries to bounce repeatedly between the virtual cluster's core DNS and the host cluster's core DNS, spiking node CPU usage to 100%. How do you break this routing loop?
Answer: the node CPU spiked because the DNS configuration created an infinite lookup loop between the virtual and host cluster resolvers. I would break the loop using these steps. 1. Identify the loop node. Check the host node CPU metrics to find the specific instances that are experiencing the 100% saturation. 2. Access the vCluster core file. Open the config map managing the virtual cluster's core DNS configurations for editing. 3. Enforce strict forwarding paths. Remove any wildcard forwarding configurations that bounce unresolved queries back to the host cluster. 4. Configure explicit upstream DNS. Update the forward directive to point directly to a static, external resolver like a private VPC DNSIP to break the recursion. Pro tip: virtual clusters share the underlying host nodes. A DNS loop inside a vCluster can easily exhaust host CPU and take down the entire physical node. Always configure your vCluster core DNS templates with explicit upstream resolvers and avoid wildcard loops that can bounce requests back to the host. Here is Kubernetes configuration demonstrating how to configure the virtual cluster's core DNS core file to use explicit upstream DNS and prevent loopbacks. Disclaimer: always test code in a non-production environment. This code configures the forward directive to point directly to our private VPC resolver IP, ensuring that any unresolved queries are routed out of the cluster instead of looping back.
Production Incident 196. You use Crossplane to allow developers to provision external cloud resources like S3 buckets and databases natively via Kubernetes. However, a configuration drift on a database resource causes Crossplane to rapidly and continuously reconcile, hitting your cloud provider's API rate limits. All infrastructure automation across the entire AWS account is blocked. How do you resolve this?
Answer: this is a cross-plane provider rate limiting failure. When a resource is out of sync or has a validation error, Crossplane's controller attempts to continuously reconcile the state with the cloud API. If this loop is too aggressive, it will quickly exhaust your cloud account's API limits, blocking all Terraform, CLI, and automated scripts. To resolve this immediately, I would pause the active reconciliation on the custom resource by adding the crossplane.io/paused true annotation to the resource metadata. Once the API cooldown period has cleared, I would inspect the logs to identify the drift error, update the resource configuration to use a longer sync interval, and re-enable reconciliation. Pro tip: poorly configured reconciliation settings can generate excessive cloud API traffic. To safeguard your cloud boundaries, review provider reconciliation settings, and implement strict alerting to flag any provider that enters a continuous reconciliation failure loop.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 197. Your database-heavy payment application crashes on startup with Vault token expired errors. You find that the Vault agent sidecar successfully renewed the token in the shared file volume, but because the application runtime does not dynamically reread the token file from disk during execution, it continues attempting to connect using the stale, expired token. How do you fix the credential sync?
Answer: this is a credential synchronization failure. While the Vault agent sidecar automatically handles token renewals on disk, the application process only reads the token file once during its initialization phase, creating a stale in-memory state during token rotations. To resolve this, I would trigger a rolling restart of the application pods to force them to read the newly updated token on boot. For a permanent, zero downtime fix, I would refactor our application code to dynamically read the token file from disk before every external API call, or configure our Vault agent to automatically send a signal like a SIOP to the main container process to trigger a configuration reload whenever the token is rotated. Pro tip: do not assume your application processes read file updates dynamically. When using secret injecting sidecars like Vault Agent or CSI Secret Store, always ensure your application code is built to detect and reload file-based credentials on the fly, or configure automatic process signals to force reloads.
Production Incident 198. A developer accidentally gains administrative access to the production namespace in ArgoCD due to a wildcard match in your central RBAC policy. They run an unvalidated sync that modifies production configurations, causing a major outage. How do you resecure the GitOps access controls?
Answer: the security breach occurred because the ArgoCD RBAC policy contained a wildcard rule that mapped too many permissions. I would resecure the access controls using these steps. 1. Identify the bad mapping. Open the ArgoCD RBAC CM config map in the ArgoCD namespace to locate the active policy rules. 2. Enforce explicit project RBAC. Remove wildcard permissions and define explicit namespace scoped roles for different development teams. 3. Implement SSO group mappings. Bind the restricted ArgoCD roles directly to your corporate SSO identity provider group claims. 4. Verify policy enforcement. Log into the ArgoCD console using a test developer account to ensure they are blocked from modifying production resources. Pro tip: wildcard rules in your GitOps RBAC configurations are an extreme security risk. Always use explicit, namespace-scoped project boundaries in ArgoCD app projects to isolate development teams, and map their access permissions strictly to verified SSO groups. Here is Kubernetes configuration, demonstrating how to configure explicit project, scoped RBAC policies in the ArgoCD config map. Disclaimer: Always test code in a non-production environment. This code defines explicit policy rules inside the ArgoCD RBAC configuration, restricting developer roles to only read and synchronize resources running inside the DevApps project.
Production Incident 199. During a critical production release, your central internal developer portal Backstage goes offline. Because your teams rely on the portal for all automated self-service provisioning and deployment status monitoring, they are left blind and unable to execute or verify the release steps. How do you recover and protect the developer portal?
Answer: this is a platform self-service outage. Internal developer portals IDPs are critical for engineering velocity, but if they go offline during an incident, they can paralyze your release and monitoring capabilities. To recover immediately, I would use our loopback CLI tools to execute the release steps directly on the cluster, bypassing the Backstage portal. For a permanent fix, I would migrate the Backstage backend database from a single local pod to a highly available external database, scale the Backstage deployment across multiple replicas, and configure an ingress-level caching layer to ensure that read-only platform metrics remain available even if the backend is slow. Pro tip: treat your internal developer portal as a Tier 1 production service. If your developers rely on it for deployment and incident response, do not run it on a single, non-replicated pod. Always configure high availability replicas and protect the database backend.
Production Incident 200. A custom internal platform API used to assign IP ranges and resource bounds returns stale data during a scaling event. Consequently, your custom platform controllers provision new namespaces with incorrect, overlapping routing configurations, causing a severe network traffic conflict in production. How do you resolve this state desynchronization?
Answer: this is a data synchronization failure inside our custom platform tools. If a custom platform API caching layer returns stale or out-of-sync IP records, the consuming controllers will write incorrect resources to the cluster, creating networking conflicts. To resolve this, I would use our administrative credentials to manually delete the conflicting namespace routing resources, forcing the custom controllers to execute a fresh reconciliation loop. To prevent future state desynchronizations, I would refactor the custom controller code to bypass local API caches and execute direct, validated queries against the source of truth database, and implement an automated schema validation step to reject any overlapping IP configurations before they are written to etcd. Pro tip: caching stateful platform metrics is a high-risk practice for controllers. If you write custom operators that allocate shared resources like IP blocks, subnets, or DNS hostnames, always query the absolute source of truth database directly and implement strict validation schemas to prevent double allocations.
Production Incident 201. A platform team updates a shared golden template Helm chart or customized base used by 100+ microservices, but accidentally introduces an insecure security context setting, for example running as root, deploying security vulnerabilities cluster-wide overnight. How do you audit and block these insecure configurations?
Answer: the security vulnerability was deployed cluster-wide because our templates lacked automated policy validation. I would enforce compliance using these steps. 1. Identify non-compliant pods. Run a wide audit query across all namespaces to identify which pods have been deployed with the insecure root configuration. 2. Deploy admission policies. Install a validating admission controller such as Kyverno or OPA Gatekeeper in the cluster. 3. Enforce security checks. Deploy a strict Kyverno policy that validates the security context of all incoming pod manifests and rejects any that violate the restricted standard. 4. Trigger graceful remediation. Notify the application teams and trigger a rolling update of the deployments to apply the corrected, non-root configurations. Pro tip: relying on developers to audit their own templates is a major security risk. Always enforce security standards directly at the API server admission gate, using policy engines like Kyverno to automatically validate the security context of all incoming manifests, rejecting any insecure containers before they boot. Here is Kubernetes configuration demonstrating how to define a Kyverno policy that validates run as non-root to block root container deployments. Disclaimer: Always test code in a non-production environment. This code configures the validation pattern, directing the Kyverno admission controller to reject any pods that attempt to run without the run as non-root security context enabled. Platform tooling and developer portals are the engines of engineering velocity, but they introduce massive operational boundaries. As we have seen in these 10 production incidents, a stable developer platform is not built on permissive, unaudited configurations. A true platform engineer does not solve a supply chain breach or a tooling outage by casually bypassing security context or ignoring rate-limiting blocks. Instead, they implement strict resource limits on CI runners, configure safe MTU sizes inside Docker and Docker daemons, enforce explicit project-scoped RBAC policies in ArgoCD, and deploy Kyverno policies to block insecure golden templates. By securing the tooling ecosystem, you protect your supply chain from internal and external compromise.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 12 to Category 13.
But even the most secure, highly automated build and deployment supply chain is useless if your cluster cannot survive a major regional disaster. If platform tooling is the factory that manufactures your workloads, then disaster recovery and multi-cluster orchestration are the insurance policy that protects your business from complete loss. When a primary cloud region goes dark, active-passive DNS routing fails, or standby recovery clusters run drifted configurations, your business stops. We must now move from individual cluster tools to the ultimate defense of the enterprise: disaster recovery and multi-cluster incidents. Let's explore Category 13.
Category 13. Disaster recovery and multi-cluster incidents.
Disaster recovery is the ultimate test of your platform's architectural maturity. In this category, we dive into the high-stakes failures that occur during cluster-wide emergencies and regional failovers, from Velero restore timeouts and silent backup corruption, to multi-cluster DNS inconsistencies, out-of-sync standby configurations, and undocumented external dependencies. We will test your ability to orchestrate zero-downtime failovers, automate backup verification, maintain configuration consistency across environments, and meet tight recovery time objectives under extreme pressure.
Category 13. Disaster recovery and multi-cluster incidents 202 to 209.
Here are the 8 production incidents covering disaster recovery and multi-cluster failures. Production Incident 202. Velero restore failure during DR exercise. Production Incident 203. Backup snapshots corrupted silently over time. Production Incident 204. Multi-cluster DNS routing inconsistency. Production Incident 205. Active-passive failover not switching correctly. Production Incident 206. Disaster recovery cluster running outdated or drifted configurations. Production Incident 207. Federation or cluster API sync failures across clusters. Production Incident 208. DR drills exposing undocumented dependencies. Production Incident 209. Recovery time objective RTO exceeded during actual failover.
Production Incident 202. During a high-stakes disaster recovery drill, your platform team attempts to restore your payments application to a secondary standby cluster using Velero. However, the restore fails because the target cluster has a different storage class name and uses isolated namespaces, causing the volume restoration steps to hang indefinitely. How do you resolve this recovery block?
Answer: the restore is blocked because the target cluster's storage classes and namespaces do not match the backup metadata. I would unblock the recovery using these steps. 1. Audit backup metadata. Verify that the source backup is healthy and contains valid volume snapshot references. 2. Configure namespace mappings. Update the Velero restore configuration to explicitly map the source namespace to the target standby namespace. 3. Enforce storage class mapping. Apply a storage class mapping config to redirect GP2 disk requests to the target cluster's GP3 storage classes. 4. Verify pod hydration. The restore engine will now successfully translate the metadata, allowing the standby nodes to mount the volumes and boot the pods. Pro tip: do not assume your disaster recovery cluster is a twin of your production cluster. Always configure explicit namespace and storage class mappings in your Velero restore commands to ensure your backup metadata translates cleanly to different cloud regions. Here is Velero CLI code demonstrating how to execute a namespace mapped restore to a disaster recovery cluster. Disclaimer: Always test code in a non-production environment. This code configures the namespace mapping parameter, directing Velero to restore resources from the production backup directly into our isolated disaster recovery namespace.
Production Incident 203. Your daily database backup jobs have been completing with green checks for 6 months. However, during an annual disaster recovery exercise, you discover that the restored volumes are completely corrupted on boot. You find that the backup tool took crash-inconsistent snapshots of your active database engine without pausing disk writes, rendering the data useless. How do you fix the backup integrity?
Answer: this is a backup integrity failure caused by crash-inconsistent snapshots. Taking automated volume snapshots of an active, high-write database engine without flushing the file system cache results in silent block corruption. To resolve this, I would immediately work with the database team to run a forensic recovery on the database tables and restore what we can from transaction logs. For a permanent fix, I would implement Velero pre-backup and post-backup hooks to execute a temporary flushing read lock on the database engine immediately before the snapshot is taken, guaranteeing that all in-memory transactions are safely written to disk first. Pro tip: green backup logs do not guarantee valid data. Treat your backups as unverified until you execute automated mock restores. Always run scheduled, automated restore tests in an isolated sandbox namespace to verify that your database engines can boot cleanly from your snapshots.
Production Incident 204. You operate a multi-cluster architecture using Core DNS for cross-cluster service discovery. However, during a production deployment, pods in Cluster A fail to resolve the address of a critical billing service running in Cluster B, throwing lookup timeouts. You find that a DNS forwarding rule has drifted on the local core DNS config map. How do you resolve this cross-cluster lookup failure?
Answer: the cross-cluster lookup failed because the local core DNS configuration was missing the forwarding rules for the remote cluster's domain. I would restore the discovery routing using these steps. 1. Audit local core file. Open the active core DNS config map in the kubesystem namespace on Cluster A for editing. 2. Configure stub domains. Add a dedicated stub domain block targeting the remote cluster's local domain such as cluster2.local. 3. Define the upstream IP. Set the forward directive inside the stub block to point directly to the remote cluster's internal DNS service IP. 4. Verify resolution paths. Run standard lookup queries inside the pods to ensure Cluster A successfully resolves and routes requests to Cluster B. Pro tip: managing multi-cluster DNS manually is prone to configuration drift. Always automate your cross-cluster service discovery using tools like Cilium Cluster Mesh or Core DNS Autopath configurations, ensuring that cluster-to-cluster lookup routes are kept in sync automatically. Here is Kubernetes configuration demonstrating how to configure core DNS stub domains to route cross-cluster service discovery requests safely. Disclaimer: always test code in a non-production environment. This code configures the stub domain block, directing core DNS to forward any lookups for resources in cluster 2 directly to the remote cluster's DNS service IP instead of failing.
Production Incident 205. Your primary cloud region suffers a complete outage. Your active-passive global traffic manager like AWS Route 53 successfully detects the failure and shifts the DNS records to the secondary standby cluster, but client browsers and mobile app users continue attempting to connect to the dead region for over an hour, completely bypassing the failover. How do you resolve this routing lag?
Answer: this is an active-passive failover lag caused by long DNS time to live TTL caching. When a regional outage occurs, your global traffic manager updates the DNS records, but because your active-passive DNS records are configured with long TTL values like 3,600 seconds, downstream client devices and recursive resolvers will continue using the cached, dead IP address until the TTL expires. To resolve this immediately during an active incident, there is no shortcut except waiting for the client-side caches to clear. To prevent this in the future, I would update our global DNS record configurations, shrinking the active-passive TTL to a maximum of 60 seconds, and implement an application-level retry and failover mechanism inside our mobile client SDKs. Pro tip: global DNS failover is not instantaneous due to client-side caching. Always run your active-passive DNS records with a short TTL of 60 seconds, and consider using a modern Anycast-based routing system such as AWS Global Accelerator that routes traffic over static, uncached IP addresses, ensuring sub-minute failovers.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 206. Following a primary region outage, you execute a manual failover to your secondary disaster recovery DR cluster. However, the application crashes on boot because the DR cluster is running outdated application versions and is missing critical configuration keys. You discover that your GitOps pipeline was only configured to synchronize changes to the primary cluster. How do you prevent configuration drift?
Answer: the disaster recovery cluster failed because its workload and configuration states drifted from production. I would resolve the drift and secure the standby cluster using these steps. 1. Audit repository configurations. Check your GitOps application definitions to verify which target clusters are actively registered. 2. Enforce multi-cluster GitOps. Refactor your ArgoCD or Flux configurations to deploy resources to both the primary and secondary clusters simultaneously. 3. Use target cluster variables. Implement environment-specific values files to allow the standby cluster to synchronize the same application versions. 4. Automate drift audits. Build scheduled, automated CI and CD comparison jobs to continuously verify that the DR cluster's namespaces match production. Pro tip: a standby disaster recovery cluster must be treated as a live mirror of production. Always configure your GitOps engine to synchronize application manifests to both clusters simultaneously, utilizing target-specific configuration variables only for regional overrides like local endpoints or replica counts to prevent configuration drift. Here is Kubernetes configuration, demonstrating how to define an ArgoCD application targeting a secondary disaster recovery cluster to prevent configuration drift. Disclaimer: always test code in a non-production environment. This code defines the destination cluster target, ensuring that our GitOps pipeline continuously synchronizes the exact same application versions and configurations to the backup standby cluster.
Production Incident 207. During an emergency failover, Cluster API fails to provision new node pools in your secondary region. The management cluster's controller runs out of Cloud API tokens due to a rate-limiting block, leaving your recovery cluster stuck with 0 available worker nodes while database pods wait to schedule. How do you recover the provisioning engine?
Answer: this is a cluster API synchronization failure caused by rate limiting. When the primary region goes down, Cluster API attempts to rapidly provision new VMs and node pools in the secondary region. If the management cluster's controller is not configured with optimized polling intervals, it will flood the cloud provider with API requests such as EC2 describe instances, triggering a rate-limiting block that stalls all node creation. To resolve this immediately, I would use our local administrative credentials to inspect the CAPI controller logs to understand the exact reconciliation storm, verifying our cloud credentials and API quotas. If necessary, I would temporarily suspend the cluster API reconciliation process to allow cloud provider API limits to cool down before resuming automation once the blocks are cleared. The controller will then successfully resume node provisioning, bringing the recovery nodes online. Pro tip: the cluster API management cluster is a single point of failure during multi-cluster disasters. Always configure your CAPI providers with strict rate-limiting limits, utilize local caching, and ensure the management cluster's IAM roles have direct, non-throttled access paths to prevent API bottlenecks during emergency scale-ups.
Production Incident 208. You execute a simulated disaster recovery drill, and your application pods boot successfully in the secondary cluster. However, the application is completely broken and throws connection timeouts. You find that the app is attempting to connect to a legacy, undocumented on-premises LDAP server that was never whitelisted in the secondary cluster's egress network policies, blocking user authentication. How do you resolve this?
Answer: this is an undocumented dependency failure. During standard cluster execution, application dependencies can easily drift or remain undocumented because they are already permitted by permissive legacy network paths. When you fail over to a clean, locked-down secondary cluster, these missing egress rules will block traffic immediately. To resolve this, I would temporarily add an emergency egress rule to our network policy to allow traffic to the on-premises LD AP server IP on port 636, restoring user authentication. Once stabilized, I would update our platform dependency database, add the LD AP server to our official architecture maps, and integrate automated egress scanning in our staging environments to catch undocumented network targets before they reach production. Pro tip: disaster recovery drills are meant to find unknown unknowns. Never assume your application dependencies are fully documented. Enforce strict egress network policies in your development clusters. This forces developers to explicitly declare every external service their container connects to, preventing silent dependency blocks during a real disaster.
Production Incident 209. A critical primary database crashes, and your organization attempts a failover to the disaster recovery region. Although the target database replicas are healthy, you breach your 4-hour recovery time objective RTO because the platform team has to manually recreate hundreds of persistent volume claims and reattach cloud storage disks, extending the outage to 12 hours. How do you automate the failover?
Answer: this is a disaster recovery execution failure. Relying on manual intervention to rebuild stateful configurations like PVCs, PVs, and ingress routes during an outage is a recipe for RTO breaches. To resolve the immediate database recovery, I would write emergency automation scripts to loop through and recreate the missing PV links. For a permanent fix, I would integrate a dedicated disaster recovery orchestrator such as Velero with automated restore pipelines, or use a multi-cluster orchestrator to continuously synchronize volume snapshots and stateful metadata between regions. This ensures that the recovery steps are fully automated, allowing you to execute a complete regional failover in minutes. Pro tip: a disaster recovery runbook is useless if it is manual. To meet aggressive RTO targets, automate your failover steps using continuous stateful replication like AWS Aurora Global Database or Portworx, and implement automated recovery scripts that can recreate your entire Kubernetes application stack in a single, verified pipeline run.
Category 13 Conclusion. Disaster Recovery and Multi-Cluster Mastery.
Disaster recovery separates theoretical architectures from enterprise-grade resilience. As we have seen in these 8 production incidents, a successful failover requires much more than simply replicating data. It requires strict management of active-passive DNSTTLs, automated Velero namespace mappings, rigorous multi-cluster GitOps synchronization to prevent configuration drift, and explicitly documenting external egress dependencies. By automating stateful restores and executing continuous, isolated disaster drills, you ensure your platform can survive a complete regional loss without breaching your recovery time objectives.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 13 to Category 14.
We have covered control plane tuning, auto-scaling boundaries, observability, security, and multi-cluster disaster recovery. But what happens when the entire platform operates under absolute, sustained peak load? In our final category, we face the final boss of platform engineering: systemic, high-scale cascading failures. These are the elusive, complex anomalies that do not crash a single pod, but instead introduce massive latency, retry storms, and systemic saturation across the entire infrastructure. Let's explore the peak of our masterclass: high-scale reliability and platform failure incidents.
Category 14. High-scale reliability and platform failure incidents.
At massive scale, localized issues transform into cluster-wide outages. In this final category, we dive into the most complex distributed systems failures an engineer will ever face, from unpaginated API list queries bypassing the watch cache and crushing etcd, to rolling deployments exhausting physical cloud routing ports, and downstream latency triggering massive retry storms. We will test your ability to design bulkheads, implement graceful degradation, and diagnose the most obscure bottlenecks hidden deep within the Linux kernel and the Kubernetes API server.
Category 14. High-scale reliability incidents 210 to 218.
Here are the final 9 production incidents covering high-scale systemic failures. Production Incident 210. P99 latency spikes under peak production load. Production Incident 211. Single microservice failure triggering massive cascading platform outages. Production Incident 212. API server becomes slow only times during specific peak hours. Production Incident 213. Pods restart only on one specific node hardware or kernel issue. Production Incident 214. Rolling deployment exhausted shared infrastructure dependencies, for example, DB connections, cloud NAT ports. Production Incident 215. Full platform outage caused by shared dependency failure, for example, centralized auth or DNS down. Production Incident 216. Large-scale retry storms overwhelming backend services. Production Incident 217. Operator or reconciliation storms saturating the API server. Production Incident 218. Massive namespace deletion stuck for hours. This concludes our 218 incident roadmap. Let's finish strong with Production Incident 210.
Production Incident 210. Your cluster is handling 50,000 requests per second. The average latency remains a healthy 50 milliseconds, but your P99 and P99.9 latency metrics suddenly spike to over 4 seconds, causing random user timeouts. You have ruled out CPU throttling and memory exhaustion. How do you troubleshoot these elusive tail latency spikes?
Answer: this is a high-scale tail latency anomaly, often caused by deep system-level queuing or garbage collection pauses. When the average latency is healthy but the P99 latency spikes, the issue is not general capacity, but momentary processing lockups. To troubleshoot, I would first evaluate application-level JVM or Go runtime garbage collection logs to see if stop-the-world pauses correlate with the latency spikes. If the runtime is healthy, I would investigate the Linux networking stack, checking if the node's network interface card NIC interrupt queues soft IRQ are bottlenecked on a single CPU core. Distributing network interrupts across multiple cores using receive packet steering RPS can immediately clear network queuing delays at high scale. Pro tip: averages lie, tail latency tells the truth. At high scale, P99 latency spikes are rarely caused by a lack of raw compute. Always investigate runtime garbage collection tuning, network interrupt CPU pinning soft IRQ, and connection pool exhaustion on upstream dependencies when hunting down microsecond delays.
Production Incident 211. A non-critical internal service like a user avatar image processor experiences a database lockup. Because the core API gateway and several critical microservices make synchronous calls to this failing service, without strict timeouts, their request threads hang. This exhausts the thread pools of the healthy services, dragging down the entire platform in a massive cascading outage. How do you implement architectural bulkheads?
Answer: this is a classic cascading failure caused by synchronous coupling and missing bulkheads. In distributed systems, a slow downstream dependency is far more dangerous than a completely dead one, because a slow service forces upstream callers to hold connections open, rapidly exhausting upstream thread pools. To resolve the active incident, I would instantly sever the connection by scaling the broken avatar service to 0 or updating the service mesh to return immediate 503 errors, freeing the upstream threads. To prevent recurrence, I would enforce strict, aggressive timeout policies on all service-to-service calls and implement circuit breakers via our service mesh like Istio to automatically trip and return fast failures whenever a non-critical downstream service degrades. Pro tip: build your microservices with graceful degradation in mind. Never allow a non-critical feature to take down the critical path. Implement aggressive timeouts and circuit breakers to instantly cut off degraded downstream dependencies, ensuring your core application remains available even if auxiliary features fail.
Production Incident 212. Every day at midnight, your Kubernetes API server CPU usage spikes to 100%, and cluster operations grind to a halt. You discover that a massive automated cron job is executing an unpaginated list command across all pods in the cluster. Because the client is requesting live data from etcd rather than using the watch cache, it completely crushes the backend database. How do you protect the control plane?
Answer: the control plane is saturated because a poorly written client is executing massive, unpaginated database sweeps that bypass the API watch cache. I would secure the API server using these steps. 1. Identify the rogue client. Query the API server request total Prometheus metrics, filtering by the list verb to identify the specific service account causing the spike. 2. Enforce pagination. Update the client script's API calls to use the limit parameter, forcing it to fetch results in manageable chunks. 3. Leverage the watch cache. Modify the client's GET request to include the resource version equals 0 parameter, instructing the API server to serve the response from its fast, in-memory cache rather than hitting etcd. 4. Implement APF throttling. Place the automated cron job service account into a highly restricted API priority and fairness queue to cap its concurrency. Pro tip: executing a global list call without resource version equals 0 is one of the fastest ways to kill a large Kubernetes cluster, as it forces the API server to deserialize the entire active etcd database into memory. Always enforce pagination and cache utilization for custom controllers and reporting scripts. Here is bash code demonstrating how to use kube control to execute a paginated list request that utilizes the API server cache. Disclaimer: always test code in a non-production environment. This code explicitly appends the resource version 0 parameter to the API request, guaranteeing the control plane serves the payload instantly from its memory cache, instead of executing a heavy etcd sweep.
Production Incident 213. Your alerting dashboard lights up with pod crash loop events, but upon closer inspection, you realize that the crashes are only happening to pods scheduled on one specific worker node. The application code is flawless, but the physical host is suffering from silent hardware memory (ECC) errors or a dying disk controller. How do you isolate the faulty hardware?
Answer: the pods are crashing because the underlying physical node hardware is silently corrupting processes. I would isolate the faulty node using these steps. 1. Cordon the node immediately. Execute a kube control cordon command to mark the node as unschedulable, ensuring no new pods are placed on the dying hardware. 2. Inspect the kernel ring buffer. SSH into the node and execute dmessage to look for low-level kernel warnings, physical disk I/O faults, or memory corruption logs. 3. Drain the remaining workloads. Safely drain the node to forcefully reschedule the remaining workloads onto healthy infrastructure. 4. Automate hardware detection. Deploy the Node Problem Detector NPD daemon set to automatically scan host kernel logs and taint sick nodes before they impact workloads. Pro tip: Kubernetes schedulers cannot natively detect dying hard drives or memory (ECC) errors. They will happily schedule healthy pods onto a node with failing hardware until the pods crash. Always deploy the Node Problem Detector to translate low-level kernel errors into Kubernetes node conditions, enabling automated cordoning. Here is bash code demonstrating how to cordon a faulty node and inspect the kernel ring buffer for hardware failures. Disclaimer: always test code in a non-production environment. This code dumps the raw kernel ring buffer with human-readable timestamps, filtering for critical hardware faults that are completely invisible to standard container logging tools.
Production Incident 214. You trigger a rolling deployment for a high-traffic microservice. The max surge parameter is set to 100%, causing the deployment to spin up 500 new pods before terminating the 500 old ones. The total pod count temporarily reaches 1,000, which completely exhausts your backend PostgreSQL connection limits and Cloud NAT gateway ports, causing a total platform outage during the rollout. How do you prevent shared dependency exhaustion?
Answer: this is a rolling deployment shared dependency exhaustion. While scaling pods up rapidly ensures high availability at the compute layer, each new pod opens its own database connections and uses outbound network ports. A massive 100% surge effectively doubles your infrastructure footprint instantly, blowing past physical database connection limits and triggering cascading timeouts. To resolve this, I would immediately edit the deployment spec to tighten the max surge parameter to a conservative value, such as 10% or 20%, enforcing a slower, controlled rollout that respects our physical infrastructure limits. For a permanent fix, I would deploy a connection pooling proxy like PG Bouncer between the application and the database, decoupling the number of running pods from the number of physical database connections required. Pro tip: pod scaling directly translates to infrastructure pressure. Never set max surge to large percentages on massive deployments, unless your backend dependencies like database connections, Cloud NAT SNAT ports, and caching layers have been load tested to support double the active pod count simultaneously.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Production Incident 215. Your organization relies on a centralized cloud identity provider, OIDC, to authenticate all internal microservices. During a cloud region degradation, the identity provider becomes unreachable. Even though your Kubernetes cluster and applications are completely healthy and running in an unaffected zone, the entire platform goes down because no service can validate authorization tokens. How do you implement resilience against central failures?
Answer: this is a shared dependency single point of failure. When every microservice in your cluster requires a synchronous HTTP call to an external, centralized system like an auth provider, global DNS, or central feature flag service to process a request, the reliability of your entire platform is downgraded to the reliability of that single external endpoint. To resolve the immediate lockup, I would temporarily enable fallback validation modes or deploy emergency break glass tokens if the architecture supports it. For a permanent fix, I would implement local JWKSJ-SUN web key set caching or an Envoy external authorization cached locally on the host nodes. This allows the microservices to validate authorization tokens against the local cache, enabling the cluster to survive transient external network outages without dropping traffic. Pro tip: hard dependencies on central services guarantee central outages. Never put a synchronous external network call in the critical path of your primary transaction flow without implementing local caching, such as local JWKS caching, graceful degradation, or circuit breakers to handle the inevitable external downtime.
Production Incident 216. A brief 2-second network blip drops connections between your 1,000 front-end pods and the backend processing service. Instantly, all 1,000 front-end pods attempt to blindly retry the failed request at the exact same millisecond. This massive, synchronized retry storm hits the backend service like a DDoS attack, completely overwhelming its compute capacity and taking it offline. How do you implement resilient retries?
Answer: the backend crashed because the front-end clients executed synchronized, unthrottled retries. I would implement intelligent backoff routing using these steps. 1. Deploy service mesh policies. Leverage your service mesh like Istio or Envoy to manage the retry logic centrally, removing it from the application code. 2. Configure retry budgets. Define a strict maximum retry attempt limit, for example, 3 attempts to prevent infinite looping. 3. Enforce exponential backoff. Ensure that subsequent retries are spaced further apart in time, giving the backend a chance to recover. 4. Inject randomized jitter. Add randomization to the retry intervals, scattering the requests over time to prevent a synchronized wave from hitting the backend simultaneously. Pro tip: naive retries are worse than no retries at all, as they turn transient network blips into self-inflicted DDoS attacks. Always utilize Envoy or Istio virtual services to enforce exponential backoff and randomize jitter on all service-to-service communication. Here is Kubernetes configuration demonstrating how to define an Istio virtual service with exponential backoff and retry limits to prevent retry storms. Disclaimer: always test code in a non-production environment. This code configures the proxy to intercept failures and automatically retry up to 3 times with a 2-second timeout per attempt, applying native exponential backoff without requiring changes to the application code.
Production Incident 217. An in-house custom Kubernetes operator is deployed to manage internal databases. However, due to a bug in the operator's logic, it fails to correctly update the status subresource of a custom object. This causes the controller to re-queue the reconciliation loop with 0 backoff delay. Within minutes, the operator generates millions of continuous patch requests, saturating the API server and threatening cluster stability. How do you stop the storm?
Answer: the API server is saturated because the custom operator is stuck in an infinite reconciliation loop. I would diagnose and halt the storm using these steps. 1. Audit API metrics. Query the API server request total Prometheus metric, filtering by the patch verb to pinpoint the runaway service account. 2. Halt the operator. Immediately scale the custom operator deployment replicas to 0 to sever its connection to the API server and halt the request storm. 3. Debug the reconciliation logic. Inspect the operator's logs to identify why it failed to update the resource status or why it dropped its error state. 4. Enforce rate limiting. Update the operator's controller runtime code to implement strict work queue rate limiting and exponential backoff on reconciliation failures. Pro tip: custom operators have deep control plane access and can easily execute denial of service attacks against their own clusters if not written carefully. Always ensure your custom controllers utilize the standard Kubernetes controller runtime library, which provides built-in rate limiters and exponential backoff queues to prevent runaway patching loops. Here is bash code demonstrating how to query Prometheus API metrics to identify runaway controllers, saturating the API server. Disclaimer: always test code in a non-production environment. This code executes a PromQL query that aggregates the total API server request rates over a 5-minute window, instantly revealing which controller or service account is generating the API storm.
Production Incident 218. A CI/CD pipeline triggers the cleanup of an ephemeral staging namespace containing 50,000 secrets and config maps. The deletion remains stuck in the terminating state for several hours. The API server is healthy, but the namespace cleanup proceeds sequentially across many resources, making extremely large namespaces slow to remove. How do you accelerate the deletion?
Answer: the namespace is stuck terminating because sequential resource cleanup is too slow to execute 50,000 individual delete operations. I would bypass the controller and execute a bulk deletion using these steps. 1. Verify the bottleneck. Run kubectl get all inside the terminating namespace to confirm that the remaining resources are standard objects rather than stuck finalizers. 2. Clean standard workloads first. Use kubectl delete all --all to instruct the API server to perform bulk deletion operations natively for standard workload resources. 3. Clear unstructured objects in parallel. Pipe the remaining API resources list directly into a multi-threaded xargs command to delete custom resources, secrets, and config maps rapidly in parallel. 4. Finalize the namespace. Once the massive volume of inner resources is physically cleared from etcd, the namespace controller will immediately complete the termination. Pro tip: the Kubernetes namespace controller cleans up resources sequentially, which is incredibly slow for namespaces containing tens of thousands of objects. If you regularly tear down massive ephemeral environments, run a script that executes bulk kubectl delete -- all commands on the heavy non-workload resources like secrets and config maps first to accelerate the cleanup. Here is bash code demonstrating how to use multi-threaded deletion commands to rapidly clear massive namespaces and bypass controller bottlenecks. Disclaimer: always test code in a non-production environment. This code retrieves a list of all namespaced resource types and pipes them into a multi-threaded execution loop, clearing out tens of thousands of objects in parallel and instantly unblocking the stuck namespace.
Masterclass Conclusion. The true role of a Kubernetes Platform Engineer.
You have now completed the ultimate 218 incident masterclass. From diagnosing expired certificates in the control plane to stopping massive retry storms at the edge, you have seen the absolute extremes of Kubernetes platform engineering. A true senior platform engineer is not someone who just writes YAML. It is someone who understands the exact intersection where cloud infrastructure, the Linux kernel, and the Kubernetes API collide. You are now equipped with the forensic troubleshooting skills and architectural intuition to keep the most complex systems on the planet running. Thank you for watching, and stay resilient.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.